Days after days, pseudoscience just a big charade, making theories they just can't explain, on philosophically biased claims. Days after days, we break away just like a renegade, so pay attention, gonna get a grade. The school and globers tell they all awake. School and globers with diplomas and a chip on their shoulder. Debate is over, mind is sober, solar system disclosure. Can't go back once you heard the facts. We make a pact, never take the backs. School and ballers and the followers that give them their dollars. They try to holler in the chat that you're a fraud, not a scholar. They hating y'all, that's why they attack. The earth is flat no matter how much they laugh. Days after days, pseudoscience just a big charade, making theories they just can't explain, on philosophically biased claims. Days after days, we break away just like a renegade, so pay attention, gonna get a grade. We school and globers tell they all away.
Got here. Okay, welcome to Skull and Glober. Sorry, a million things going on. Cool, we made it. Discord can hear us now. Let me pop over, share the screen with them. So, welcome to Skull and Glober's episode 25. Sorry that we're late. I got caught up on another stream, and I've been trying to set up some alternative way for you guys to support the channel. So I'll go ahead and let you guys know. YouTube demonetized me this week a couple days ago. So you guys may have gotten some emails talking about how your membership has been paused. We were demonetized, and it said for harmful content. So needless to say, that's not a very good situation for me. And we can cover it a little bit later, but Okay, we're back. Hopefully we're back. And let me share this screen with Discord. All right, I don't know exactly what's going on, but whatever. Stuff happens. So in case you didn't hear me, I got demonetized this week. What a coincidence. Yeah, but there is now. So I got demonetized this week. They just said harmful content. So all the members, there were people that were 15, 16 months, I think. They stopped all the memberships, no super chats. You know how it goes. So obviously that sucks. I don't really want to talk about it because that's very unfortunate situation for me. And that's what I get, I guess, for depending on YouTube at all. So whatever. If you want to super chat during the show, there's a link in the description. It says donate to the stream here. And then underneath it, there's a community that we're going to launch, so we don't have to worry about them anymore. Then underneath that is local. So for super chats, it's the first stream, or the first link. Okay, cool. And then the Earth Awakenings Discord is also in the description, so shout out to them for having us on. And it's also the QR code in the thumbnail. All right, this is crazy. Can't John Zerga help you get monetized again? What? What? Anyway, no Rockfin. Well, Rockfin was going, and then my whole computer just like went insane. So Bill Gates is not very happy with me right now, I don't think. I don't know. But anyway, we're going to get into it, and I will say I didn't have time to fully prep a ton, but it's like the ether has spoken, and we're supposed to talk about quote-unquote gravity and really the electric nature of everything, which kind of ties into the last two questions. So I'm going to kind of run off of that. I'm sharing with Discord. Let me come to... There we go. Okay. All right, cool. Let's just go ahead and get started. Like I said, if you want to ask any questions or super chat or support the stream, links in the description. Probably a blessing in disguise. Sorry, Discord, be patient with me real fast. Let me tell them this. It's probably a blessing in disguise because YouTube takes 30%. They constantly censor us, etc. Like, if you actually want to support the channel, and obviously you don't have to, but if you do, the link in the description only takes way less than 30%. Hopefully there should be no censorship. And so there's that blessing in disguise. Trust me, I get it. You guys like to see your name in big colors and pop up, and I get that the member thing sucks. I'm going to try to appeal it and get it back, but it is what it is. There's nothing I can do about it. So I tried. I'm trying to appeal it. It is what it is. I will go through. I'll even try to show your chats on the screen, and if you guys will help me out, testing that out. Also, Streamlabs wouldn't let me accept tips. I don't know what's going on. They're like attacking me, bro. It is what it is. So that's why we got the locals in the description, because locals is like Rumble's version of Patreon. So hopefully we can get a community started up there. Also, we have the Nas, the second link. That's another community that's going to give you exclusive access to a VIP Miswits Telegram that you can only get in if you have the membership. It'll be a little community, and we're going to also host exclusive events there. And then you can sign up for tiers and donate to the stream tonight with the first stream. So I know it's a bunch of stuff. There's stuff everywhere. It is what it is. Greatly appreciated anyone that supports on any of three of those, and we'll build it up to be really dope, and it'll end up being better than YouTube ever was. So screw YouTube, and sorry to the members that had been Miswits for that long. But they're coming at you, boy, which is crazy because I don't even talk about crazy stuff anymore. I just talk about the Earth on YouTube. So it's like, what's going on? What's really going on? You know? All right. Anyway, back to the stream. So, Scoring Globers, episode 25. What's your Cash App? $Witsit. I'll read it all off at the end of the stream or throughout the stream. All right. So the questions, we're going to run through them again. Number one is, can you provide any exclusive evidence that the Earth orbits around the sun? I'm not sure why it's showing me on YouTube. Anyway, this is craziness. Okay. Second question is, can you provide any exclusive evidence that the sun is 93 million miles away? Third question is, can high-frequency radio waves and microwaves propagate through the curvature of the Earth? Trust me, I get it. It seems like they're redundant at this point, but we need sufficient answers to justify taking them off the list. Grifters gets it. You can do better than that, bro. Can you have equipotential lines in a vertical electric field without two Gaussian surfaces? And the next question is, can Newtonian gravity and the claim of Earth's orbit both be true simultaneously? And the third question, the last question, which I honestly just threw up there, is, would an electric current create a downward bias? So would a downward electric current create a downward bias? That's the question. Meaning it's a yes or no question. It's a closed question. We can obviously discuss it afterwards, but you have to answer the question. So would an electric current create a downward bias? That is the question. Not, but what if it changes? But what about negative and positive? But that's not good enough for gravity because I don't understand it. It's, would an electric current create a downward bias? That's the question. Okay. So we'll kind of go through the questions again real fast. Dude, I had so much stuff pulled up that all got closed. It's crazy. Such is life, eh? All right. There exists no exclusive evidence that the Earth orbits the sun. And I think that eventually, now that the list is kind of full, we'll start knocking them off from the top. So we don't have to literally cover the same information every single time. They're not going to answer the question, let's be real. We'll just keep it in the cut if they ever do. This is so harmful. I know it says harmful content. That's all it says. Like, it doesn't even specify. It's such a joke. All attempts to measure/detect the alleged orbit of the Earth around the sun have failed due to no exclusivity of evidence. The kinematic equivalence between geocentrism and heliocentrism. A geocentric model, absent of dark matter and dark energy problem, is significantly more viable. So, long story short, there's no actual evidence that the Earth orbits around the sun. All evidence shows us the opposite. The current mainstream model of the globe is that it's just an illusion. And sure, it looks like we're in the center, but there is no center, and everywhere it looks like it's in the center. And you could just as well put Mars in the center, or Jupiter in the center, or Neptune in the center. Everything is the center, but there is no center. And the reason that you can't detect the orbit of the Earth around the sun is because it isn't detectable, because of relativity. And what that means is that in 1905, Einstein proposed the theory of relativity to save the orbital claim. And by 1915, he had to kind of backtrack and flip-flop to the extent that he then had to concede that a geocentric model was equally viable, which is pretty ironic. So, does sun move around Earth? Does Earth move around sun? That's a kinematic question. There's a kinematic equivalence, and actually there's even a dynamic equivalence. So what this actually means is that the geocentric position, even in their own paradigm, is equally valid. Kinematically, not even a dispute, and dynamically they'll dispute it, but they're wrong. So that means that the geocentric position is actually way more viable because you don't need dark matter or dark energy. And so maybe we can really cover that if anyone will actually address it. So there exists no exclusive evidence that the Earth orbits around the sun. And in fact, the geocentric position is significantly more viable because it doesn't have the dark matter or dark energy problems. It's really GG's right there, if we're going to be real. It's like, thanks for playing. Your model's wrong. Okay. There's no exclusive evidence supporting the claimed distance to the sun of 93 million miles. So the claimed radar bounce was never successfully done, as the background solar noise of the data drowns out any attempt to truly identify the alleged radar echo. An interesting part to note here is, how come it took us looking into it to tell you that? How come for years we've heard, we know how far away the sun is, we sent radar to the sun? People like MC Toon and then others who mindlessly parrot what he claims have been saying that we verify the distance to the sun with a physical measurement by actually bouncing radar off of the sun. And they say this with the utmost confidence. They go around saying it. If you read the paper that he has, for example, on his own site, it point blank tells you they were not able to distinguish between the alleged radar bouncing off the sun and the actual solar noise. It was merely theoretical, mathematical models. In fact, the models didn't even really work. They had to create and introduce entire new computing models. And they admit that there's no way they can actually definitively claim whatsoever that the radar successfully echoed and or bounced off of the sun, because the solar noise is so much stronger than it. Okay, and that's actually, they tried to get the math to interpret it assumptively based upon the Kerr model, which isn't even the mainstream model for the sun anymore. So again, the point I want to make here is, why is it that they left that part out? That seems like it's dishonest, right? So, in addition, the tests from the late 50s to the early 60s used an archaic Kerr model of the sun, required assumptive mathematical models, innovating coding methods, and still did not result in any truly reliable results whatsoever. Additionally, the sun in the heliocentric model is supposedly a black body, which is said to absorb all wavelengths of light. Of course, radar is wavelengths of light. So, of course, including radar. The trigonometric method using the transit of Venus is the primary second claim. It is entirely unreliable and unfeasible in reality due to the required length of the baseline being so long. The maximum you could have is the quote-unquote diameter of the reified presupposed globe that's been falsified. In reality, due to the required length of the baseline, atmospheric and temperature disturbances, game over, required precision of observational synchronization, and resolvability requirements. It also requires presupposed metrics of the globe model in the first place. Well, that isn't sufficient, is it? No, that's called a reification fallacy and affirming the consequent. And, of course, the data itself is admittedly not reliable. And when I say admittedly, I mean NASA explains that this isn't an actual feasible or tenable test in reality. In 2024, it's not. But they want to tell you that people did it hundreds of years ago. So there's that. And of course, if the sun is in fact 93 million miles away, we would have parallel rays. They would be evenly distributed across the entire side of the Earth that was illuminated. Then, of course, if this is an actual hotspot from the sun on the clouds from about 100,000 feet up, that would refute that claim. You cannot have a localized hotspot directly under the sun on clouds if the sun is 93 million miles away with evenly distributed parallel rays. That is not possible. So, okay, we'll go to high frequency radio waves. And the ionosphere is said to have a frequency range of about, I know that it's repetitive. That's why I'm going to start changing up the questions. I don't want you guys to feel like it's always the same. But I think that we should really understand this stuff now, right? The ionosphere is said to have a frequency range of up to 40 megahertz, and this ionized region of the atmos allegedly reflects radio waves back down to the Earth to explain why line of sight transmission far exceeds the geometric limitation of the globe Earth model. World record transmissions ranging from 100 megahertz to upward of 100 gigahertz have been sent line of sight far beyond this assumed physical geometric limitation. These frequencies are far too high to reflect off the ionosphere, thus falsifying the spherical Earth assumption. Okay, we also covered that there are equipotential lines of the Earth's vertical electric field that are measurable. This results in a downward electric current. So we have 100 volts per meter. Equipotential surfaces, I call them lines so people understand. They are parallel lines. Now, are they a construct? Sure, believe it or not, there aren't actual physical lines out on the Earth, right? But what it is an equipotential increase, meaning that there's an equal increase of potential per distance, specifically 100 volts per meter. Does this fluctuate? Sure, there's all kinds of disturbances and fluctuations within the electric field, but it is a uniform distribution across the Earth. Oh, did you just contradict yourself? You said it changes, but it's uniform. No. The uniform distribution of the charge and the additional fluctuations within it after the fact are two separate things. Okay, so we have electrical activity that causes fluctuations, sure, but the actual physical distribution of the charge itself is uniform. There's a vertical electric field, equipotential surfaces. They're actually horizontal to each other and the Earth, this requires two perpendicular Gaussian surfaces. And that results in a downward electric current. What they would say is that positive charge builds up, and then the surface of the Earth is negative, measurable to 400,000 coulombs. And so there's a current that goes down. Now, if you watched this week's Glowbusters, and someone was asking me right when I jumped in, go watch our show on Glowbusters this week, and we thoroughly explain this. So, atmospheric ions created by cosmic rays and natural radioactivity move in the electric field, so a very small current flows through the atmosphere, even away from thunderstorms. Near the surface of the Earth, the magnitude of the field is on average around 100 volts per meter, oriented such that it drives positive charges down. What was our question again? It was, would an electric current create a downward bias? Okay, let's keep the question in mind here. So, such that it drives positive charges down. The electric field must be either parallel or perpendicular to the Gaussian surface. Interesting. Very interesting. Here's a depiction, and of course we have a downward current. So if you see the person sitting there, the field effectively wraps around them. Well, it's because they're on the ground. So in reality, there's no such thing as negative or positive charge. And any physicist worth his salt will tell you that they were arbitrary denotations. You could flip them around. You could say negative is positive and vice versa. There are no negatives in nature, period. It's merely a construct that we've come up with to differentiate phenomena. Precisely that there's the process of charging up and there's the process of discharging. And these act different. And when a system that's charging is introduced to a system that is discharging, they will actually, quote unquote, attract. Now, in reality, they're just accelerating towards each other, just like if I open up gas, like a container of gas near a vacuum chamber, right? It will seek equilibrium. It's the same thing. One system has an excess of charge and is getting rid of the rest. One system is still charging up. It hasn't reached its capacitance, which means its threshold for electrical storage. So they move towards each other to equalize. And this is what all of physics is. All physics is simply pressure mediation. All things seek equilibrium through pressure mediation. So, long story short, just so that you understand what's actually happening is that the air, if you will, is charging up. The Earth is discharging. So as things begin to charge up, it's seeking a place to equalize. Where does it do that? Towards the Earth. And there is no way to eliminate this, because if you get a Faraday cage with a vacuum sealed chamber, there still exists vacuum permittivity. The electric field still exists within it. And we've even done the test to prove it, showing that the vertical gradient still exists inside of a Faraday cage. We've actually measured it inside the cage. As you get higher, the vertical gradient is still measured. Measurable difference in electric field with a vertical gradient, even in a Faraday cage. There's no way to truly eliminate this. Okay. So here is how we can replicate it on the Earth. We can have two metal plates. These would effectively serve as our Gaussian surfaces. What people will say is, there's no such thing as a Gaussian surface. They don't exist. They're just hypothetical. They're just mathematical. I'm trying not to go too fast, by the way. So, well, yes, they come from Gauss's law. They are a construct that we use, right? They're mathematical. But they are not merely mathematical. You can use the construct just so that you can idealize situations to try to quantify what's going on. But you can replicate the phenomena that that actual construct is built upon. It's a real physical phenomena. Precisely what you can do is you can take two metal plates that serve as your Gaussian surfaces. You can put them parallel to each other, and what happens is it creates a finite volume for the charge between the plates to distribute. And the way that the charges are distributed gives you a vertical density gradient, because you have a vertical electric field perpendicular to these two parallel plates. It creates finite volume. And because the charge distribution can be uniform, it gives you a uniform vertical electric field because of the planar surface. If you were to take a sphere and put it in that field, there would be radial distribution. So if you look here, you see that these lines are, of course, parallel to each other. Well, what would that be on a sphere? It would be concentric circles, right? So if you have charge distributing on a sphere or within an electric field, a sphere that's inside of an electric field, you'll have radial distribution. It will not be uniform. It's just a fact. It can't be. In fact, there will be a significant drop-off. It's radial. So it cannot be uniform vertical density gradient or vertical electric gradient perpendicular to the Earth. That is impossible. It's quite literally impossible. You can prove it's impossible. It can never be done. No one will ever do it. Okay, so anyway, when we replicate it, for example, we've taken a Van de Graaff generator, connected it to the plates, and when you introduce the charge from the Van de Graaff generator, just a belt, and you spin the belt and it creates friction, and then creates electrostatic charge. You can flip this field. So when you flip the polarity of the field, whatever object is on the bottom plate will actually go up. So now we've performed actual science, right? The question is, again, would a downward electric current create a downward bias? Now we're going to scientifically test the idea by manipulating the independent variable of the electric field. And when we manipulate this variable via electrostatic manipulation, we actually change the direction at which things fall. We can even change the weight of an object, the measurable weight. We can change the rate at which they fall down and the direction in which they go. They can even go up. So we've actually proven scientifically that when you manipulate the independent variable of the electric field and or electrostatics, you can actually change the direction of the object. Now, we also just established it's always present everywhere. You can't get rid of it. And we also know that all objects are intrinsically electrostatic. So what we now know is that this is playing a role in the phenomena on the Earth. Okay. So here is another depiction, right? You have the volts increasing as you go up. Now, they'll say that this stops around 50 miles. That's not what this says, but that's what they'll say. And they claim that the ionosphere acts as the second Gaussian surface. So they act like this little circle around here, which is a concentric. And again, you see, in reality, you can't have a uniform field, right? You can't. It's impossible on a sphere. And they'll say that the ionosphere acts as a Gaussian surface. Well, for one, can anyone show that actually being a thing? Of course not. Two, they actually claim that the ionosphere fluctuates significantly. I mean, to such an extent that when we shoot radio waves way too far line of sight, sometimes they'll say, oh, see, if you look at the angle, assume the sphere, assume the distance on the sphere, then it had to bounce down at 37 miles. So the ionosphere was polarized enough or ionized enough at 37 miles that it bounced back down. The next day, you can send it even further, and they'll say, okay, let's do the math. Okay, it had to be 52 miles. So they claim that this fluctuates constantly. If they're going to claim that it is, in fact, acting as the second Gaussian surface, which is what Feynman does, and we'll look at his paper, right? Well, then they got a problem, because that would mean the electric field is significantly changing and varying. There would be no uniformity, not even a semblance of uniformity, all over the Earth. That would be impossible, because it would actually be going up and down in different places of the Earth constantly. As in there would be no equipotential all the way down to the surface, because you're changing the volume. And again, you can't have uniformity anyway because of a spherical distribution. So what does Feynman do? Well, he shows you parallel demonstrations. So horizontal parallel demonstrations shows you parallel physical plates. And then all of a sudden, this isn't Feynman's depiction, but this is a university. They'll talk about, oh, it's a sphere, it's the ionosphere. Well, that's not reality. So the question of the day is actually not that. Of course, it is, if you have an electric current, would there be a downward bias? And let's see if I need to even cover this. No. Okay. And I will briefly cover what we covered last week. As you can see, it's just the old PowerPoint. But let's first cover the two principles of logic. I just had this conversations while I was actually late. It seems people just can't let it go, right? People want to say that Einstein and Newton are both true, and that Einstein didn't replace Newton, just expounded upon it, right? But that's not what happened. Because let's just talk about basic logic, and I think that Toby was making a good point in that last show, and I was trying to explain what he was saying to them. what this belief system does is it renders you useless in terms of logic. It makes you hold two simultaneously contradictory beliefs to be true, right? So you have the two first principles of logic. I mean, this is the most basic fundamentals of logic that exists. The first one is the law of non-contradiction, which is contradictory claims cannot be true at the same time in the same sense. The second principle of logic is the law of the excluded middle, which is that something either is or is not. So when we look at Newton and Einstein, and Newton says an object will continue in a straight path unless an external force acts upon it, then Einstein says an object can go in a curved path without an external force acting upon it. Those are opposite claims. Newton says the object will continue in a straight path and will only deviate from that straight path or curve if a force acts on it. Einstein says the object can curve, deviating from a straight path with no force acting on it, meaning those can't both be true. Newton said there must exist an ether because he had no time variable, said gravity was instantaneous action at distance requiring mutual contact. Now, it's not just that Newton said it, it's just basic logic. If there was some type of quote-unquote force acting through the vastness of space, there must be some medium touching everything in space at the same time that it could be instant, right? That's the antecedent to instantaneous action at a distance is a medium. So why he suggests that there was an ether. Einstein says there is no ether. Specifically, that can have mechanical motion applied to it. He ends up saying, of course you need some type of ether. So Newton, there must exist an ether. Einstein gets rid of the ether. There is no ether. These are opposite claims, meaning they can't both exist. Newton, space is absolute and fixed. Einstein, space is specifically not absolute or fixed. In fact, nothing's absolute except for light. And that is in a reference frame because light is absolute in all reference frames, but it's an absolute to measure against, to quote Einstein. It's funny, while the Leo guy was freaking out saying it's not absolute. It's like, well, you disagree with the guy who came up with the theory that you believe in. So, and that's okay, whatever. So again, Newton, space is absolute and fixed. Einstein, space is not absolute and fixed. These are opposite claims. They cannot both be true. Newton, gravity is a force. Einstein, gravity is not a force. These are opposite claims. They cannot both be true. So, and then what we'll do is actually go all the way back to the beginning here. And we covered that pretty extensively in last week, but would an electric current create a downward bias? And what I'm going to do is I'm going to actually share a different screen real quick, and then we'll open it up. So let's just do it like this. We're going to look at Feynman's lecture real quick. All right. Oh, let me share with the Discord. Sorry, guys, I forgot. Where is my stream engineer? Okay. Very simple. You can go to Feynman lectures from Caltech. You can go to atmospheric electricity. And I suggest everyone reads it, but of course you can just type in current if you want to see this specific portion. That's important. It says, ordinarily, the equipotentials are parallel to the surface, but when, what does that say? But when you are there, the equipotentials are distorted and the field looks somewhat as shown in figure 9. Which is right here. When you're there, like we showed earlier, it distorts relative to you because you're on the ground, right? So we have equipotential lines when we covered that. So you still have very nearly zero potential difference between your head and your feet. There are charges that come from the earth to your head charging the field. Some of them may be discharged by ions collected from the air, but the current of these is very small because air is a poor conductor. I got this blown up so hard, it's hard for me to read. Okay. There are charges that come from the earth to your head, changing the field. Some of them may be discharged by ions collected from the air, but the current of these is very small because the air is a poor conductor. Now, that was repetitive, but it's important. Another thing that can be measured, in addition to the potential gradient, is the current in the atmosphere. So obviously the first question is there a downward electric current on the Earth? And for years, globe Earth proponents denied this. Denied it. Outright denied it. Gaslit me about it. Said I was making it up and I was insane. We had to go back and forth 7-8 hours. I mean, it's just like insane. Okay. So the first question is there a downward electric current on the Earth? The answer is obviously yes. The current density is small, about 10 microamps across each meter parallel to the Earth. There is evidently not a perfect insulator, and because of this conductivity, a small current caused by the electric field we have just been describing passes from the sky down to the Earth. What this also means is when you get higher and you have less air, you're going to have more current. Well, where is it going to go? But so what's interesting is if there's a surface at the top, you can have a totally different phenomena going on. And we'll get into that when we start destroying satellites in 2024 and the Globers cry about it. So, all right. So, just read it again. The air is evidently not a perfect insulator, and because of this conductivity, a small current caused by the electric field we have just been describing passes from the sky down to the Earth. Again, the question is, if you have a downward electric current on the Earth, would that create a downward bias? All right. And the voltage gradient observed at any particular place on Earth's surface also varies greatly because roughly the same current flows down from high altitudes in different places. And the varying conductivity near the Earth results in a varying voltage gradient. And there is fluctuations within the field depending on certain activities. And then here's an important part. Although the electric current density in the air is only a few microamps per square meter, there are very many square meters on the Earth's surface. The total electric current reaching the Earth's surface at any time is very nearly constant at 1800 amps. The reason this is important is what do they say about what do most globe Earth proponents say? Why does everything fall down? And why does everything fall at the same rate? They don't. They provably and objectively do not. So what happens then? You say, well, look, here's very precise gravimeter measurements, right? And you're dropping the same object in the same location, and the rate at which it falls changes. So it's not falling at the same rate. Oh, well, we can just fluctuate mass around, even if we can't actually verify it, and then we can say it is still falling at the same rate. No. So anyway, and we can cover that too. I have a paper that shows that during thunderstorm activity, or if there's any change in the electric field, the object falls at a different rate. So we see a naturally occurring phenomenon that when there's fluctuations in the electric field, the object falls at a different rate. So they were like, oh, well, maybe it's the mass of the clouds, right? Because typically when it rains, they'll say it's the mass of the rain. So they try to say maybe it's the mass of the clouds. What they found was that they excluded that as a possibility because there would be a bigger cloud than there was previously, but the effect would be the same, right? And the effect wasn't matching the mass of the clouds. So one, it was showing that the mass of clouds was having really no measurable effects whatsoever, and that there was something else. And so their conclusion was, all we can say definitively is that it is not a gravitational effect. Well, based on your definition of gravity. So all that to say, they say objects all fall at the same rate. It's constant. Why is there constant downward acceleration? Like, no, there's not. It's not, though. Okay? It's very nearly constant. What a coincidence. The total electric current reaching the Earth's surface at any time is very nearly constant at 1800 amps. Now, this is them actually assuming the size of the Earth and then compiling the total, right? This current, of course, is positive, quote unquote. It carries plus charges to the Earth. Of course, there's no such thing as plus charges, just like there's no such thing as little charge carrying particles of matter. This current, of course, is quote unquote positive. It carries plus charges down to the Earth. So we have a voltage supply of 400,000 volts with a current of 1800 amps, a power of 700 megawatts. With such a large current coming down, the negative charge on the Earth should soon be discharged, which is like, but how did it exist longer than half an hour since it was discovered? And they just explain that there's constant activity going on. Now, what is very interesting about this is people will say, oh, 10 microamps per square meter. that's not doing anything. Well, yeah, that's per square meter. So that's a small amount. Now we're talking about the entirety of the Earth. There's a ton of electric pressure pressing down the Earth at all times. It's inescapable. So what's one question that we get? We'll wrap this up and open it up. What's one question that people say? What about when the electric field flips? Why don't things float? Okay. The electric field never truly flips. Portions of the field will temporarily flip because of the different ratio of charge. So, just like when you go outside in a thunderstorm, your hair will stick up. Just like certain beetles and stuff, they like just fly in thunderstorm activity. Okay? So yes, smaller, lighter objects like your hair or a beetle are affected when there's that temporary flip of the electric field. What does that show us? That the actual direction and vector of objects going up and or down is directly affected by the electric field of the Earth. Just like we did the test ourselves and we proved it. Just like the thunderstorm activity shows with the gravimeter in a vacuum-sealed chamber that the object's falling at different rates. Right? So the important part here is that the whole Earth's field would never flip, so there's still an overall net downward electric pressure on the Earth as a whole. Now, here's the other question that people always ask. Like, it's the same type of question as if the field flipped, then why doesn't everything fly up? Why doesn't it float? Right? Because they're so ingrained with the idea that there's this immense force pulling everyone down to the center of a ball. Even though that's not what the mainstream model is anymore, it can't be a force pulling anything down. There is no attraction. It's a medium that's not a medium, but it's bending and warping and acting like railroad tracks, and objects basically follow the railroad tracks down into the gravity well. They're just being guided, that nothing is pulling on anything. Okay? But people think this from a young age. They're like, oh, well, if I'm upside down on a ball, something must be pulling me down to the ball, right? And so that's what they think that we need to replace. No, we're going to just talk about what's real, what's measurable, what's provable. We're going to do experiments. We're going to manipulate that variable, prove it causes and manipulates the effect of things going up and or down. That's what we're going to actually do. So people say, well, if the electric field flips, why doesn't everyone float? Or if I drop an object that's negative and positive, why doesn't one go up and one go down? Or why don't they fall at different rates? These are the questions, right? And I've tried to answer them so many times, I'm not sure what the disconnect is here. But, okay, an object has quote unquote weight. What is that? So why does the object go down? Well, it has weight. So we have a few questions here. One would be, why down, not another direction? The answer is, on the Earth as a whole, there's tons of electric pressure coming down onto the Earth, which goes back to our question. If there's a downward electric current, if there's a vertical electric gradient, would that create a downward bias? And the answer is, of course, objectively, yes. Of course it would. So now the entire Earth is being pressed down on by this electric pressure, which is provable, it's measurable at any given times, even within the globe models, because it's assuming those sizes, right? 700 megawatts. So with a supply of 400,000 volts with a current of 1,800 amps, a power of 700 megawatts. Okay? That's why it says with such a large current coming down. So the object that's what sets our down in this realm. And if you believe in gravity and all this, you still have to acknowledge that. That's why Walter Lewin, one of the most famous professors from your side, of course, says, well, when we're talking about the Earth, everything on the Earth is electric. Like, all the phenomena we see on the Earth is attributable to electricity and to the electric field and to the electric nature of all things, because, of course, even on the smallest scale, electrostatics is 10 to the 36 power stronger than gravity's even claimed to be. It's not until you get out into space on the planetary scale that you would then begin to account for gravity. Okay, so then that question of, well, why doesn't a positive object and negative object fall at different rates or go different directions? Well, let's get precise about this. So an object, depending on how big it is, you have just 10 microamps going through like a square meter, right? So it's not a ton in that small little isolated area. It's just a good amount overall at any time. So it's very nearly constant, and objects fall because they have weight. So what is weight? Right? We're basically asking, if an object is positive or negatively charged, why isn't able to overcome its weight? That's the question. Well, okay, what is weight? Supposedly mass times gravity. Mass is in this context just volume times density. And gravity is just downward acceleration. It's the effect that things fall at roughly the same rate. It isn't constant, but we could just replace that with little a. So weight equals volume times density times little a, acceleration. Okay, that's what it is. So what's the cause of that? If we're trying to figure out why isn't it overcome, then we have to understand what it is. Okay, and volume times density means density is an important part to figure out here if we're going to figure out what weight is. That's the compactness of matter. So whatever's holding the matter together, giving it a certain compactness would be the cause of the density. Now the medium has another density. It's also intrinsically electrostatic, as is the density of the matter, because all molecular and intermolecular attractive forces are electrostatic in nature, with or without the atomic model. We know that everything's comprised of this fundamentally, right? So then it interacts, and there's pressure mediation from the object and the medium, and it's what we call buoyancy. What's the causal mechanism of buoyancy? That there is a down. So sometimes things go up because the buoyant force is strong enough to overcome it effectively, or things around it would be pulled down, as some would say. But really, the buoyant force, based on the pressure mediation, overcomes that downward bias, right? Just like in any other paradigm, the globe paradigm, it's like, oh, gravity's being overcome, quote unquote, by buoyancy, being countered. Okay, so the point is, the same thing goes the other way. The buoyant relationship is so much stronger than that weak downward electric bias that things still go down. Now the question is, well, wouldn't they fall at different rates? Well, you would have to introduce a lot of electrostatics to say, change the rate at which something like your phone falls, or to change the direction that your phone goes. You can make iron filings fall at different rates with a small little Van de Graaff generator. You can make them float. And here's the kicker, bro. Physics is scalable, bro. So if it happens there, it happens everywhere. Okay, and we'll talk more about it because I don't want to just show you guys this one screen. But the point is that physics is scalable, and so if we can prove it on that scale, it still happens. It would be akin to saying, oh yeah, the ping pong ball floats, and you can call that density, but until you show me the world's biggest ping pong ball, then density is not real. Buoyancy is not real. It just would be ridiculous, right? So long story short, the pressure mediation caused by the density relationship of the object and the medium creates what we call buoyancy that's much stronger than this electric bias. And things, to actually measure if they fall at different rates, we would have to get very highly precise, seemingly interferometry measurements of objects falling, right, with different charges. And it wouldn't change much because it's relative to the weight of that object. So you have to get something really small, change the charge significantly, and then measure if they fall at different rates. I guarantee you will see that they do, just like in the gravimeter, we see that they fall at different rates. So when people ask me, why don't things that are positive or negatively charged fall at different rates? It's like, no, we literally do see when the electric field changes, objects fall at different rates. We literally see that whenever I flip the polarity of the field, an object will flip. So it's actually based on the actual electric pressure and which way it's pushing it and pressure mediating relative to its density relationship. So hopefully that explains it, but we can talk about it more in depth, but it's very simple. The question is, let me come back over to the question. Would an electric current create a downward bias? That's the question. So in conclusion, we can discuss any of these questions. And I know that was more of me just kind of ranting because I didn't put together a full PowerPoint, but give your boy a break. So you guys can answer any of the questions. Can you provide any exclusive evidence that the Earth orbits around the sun? If not, you have a major problem because a geocentric model wouldn't have dark matter or dark energy problems. It would be significantly more viable. And all of a sudden, the fact everything makes it look like we're in the center is because we're in the center, as opposed to it's all a massive illusion. Can you provide any exclusive evidence that the sun's 93 million miles away? We covered the radar bounce, we covered the transit. Can high frequency radio waves and microwaves propagate to the curve of the Earth? The answer is, of course, no. And so the question is, well, how come things significantly higher than 40 megahertz, even higher than 400 megahertz, go incredible distances that would require them being reflected, but they can't be reflected? Next question, can you have equipotential lines in a vertical electric field without two physical Gaussian surfaces? The answer is no. The follow-up is, of course, can you have a uniform vertical electric field with equipotential surfaces on a sphere without a physical surface above. Next question, can Newtonian gravity and the claim of Earth's orbit both be true simultaneously? We brought this up because people still don't understand Michelson-Morley. They don't understand why Newtonian gravity was thrown out. I was talking about it earlier. People literally don't get it. So we have to pull Newtonian mechanics away from them. And then the last question is, would an electric current create a downward bias? Okay, so I'm going to open up the chat, and just so you guys give you guys a reminder of how it works. We give like a globe Earth proponent gets to jump line basically, right? Like when little goofy Shapiro is somewhere, he lets the leftist ask the question, right? Same type of thing. We want to be respectful and let each other finish, etc. And ideally, we want to address these questions because they're major problems for the globe Earth. All right. So that is the whole thing. And cool, we'll just open it up. So what you do is you raise your hand if you want to jump on. We'll bring you up as you raise your hand. If you want to address any of the specific questions. Just a reminder, this is not like let me jump in the Discord and then say, but if the Earth's flat, how does this work or whatever, right? We have very specific questions, and I'll constantly pull them up on the screen. Oh, I forgot to change it for you guys, but on the Discord, you'll be able to see it. And let's go from there. Okay, now let me just move around and get the Discord ready. And then I will read all the chats. If you guys sent anything into the new platforms, where we will catch up on all the chats and read the questions. All right, I think we're good. Let me get Discord on the screen real quick. Okay, boom. Yeah, what's up, man? I haven't talked to you in forever, bro.
Of the effect of gravity on the motion of antimatter. So they tested this at CERN using, it's hydrogen and anti-hydrogen and seeing how both of them were affected by gravity. And their results suggested that they were the exact same.
Okay, sorry. I realized that the Discord wasn't coming through the YouTube. I was fixing that. Okay, let's try and keep it like somewhat ordered. So first thing, just to clarify. So I didn't speculate that any object, if one's negative and positive, will fall at different rates. It's if the charge itself is strong enough to overcome the buoyant relationship, which is going to give it a certain like momentum or type of motion. It's going to set it down or up, right? That's going to be relative to like its weight, really, because its volume and density is intrinsically electrostatic, holding it together with compactness, blah, blah, blah. The buoyant relationship, the pressure that mediates between that object and the medium is pretty strong. And so in order to overcome it, you're going to have to introduce quite a bit of charge, right? Just like with our Van de Graaff generator, we're basically moving like Mount Everest in scale to the plates of what like a plain Earth would be without really making definitive size claims, right? And we're introducing this small little Van de Graaff generator is introducing some charge, and then we're flipping like iron filings and paper and styrofoam and hair or whatever up. So it has to be strong enough charge. That's the point. That's why I brought up, like hair will change when the surrounding charge is then transferred to the hair. Your hair will go up. Beetles fly like crazy during thunderstorms. So, long story short, I do think that they would fall at different rates if there was enough charge introduced in ratio to its size or buoyant relationship with the medium. When it comes to, and that's actually been proven with interferometry measurements in gravimeter vacuum sealed chambers. When it comes to what you said about CERN, I didn't really follow it because I was trying to fix those streams. So can you repeat what they did at CERN or whatever?
Yeah, I was just pointing out that in 2023, CERN did an experiment about the effect of gravity on the motion of antimatter to see if it was affected by gravity in the same way as regular matter, even though it has an opposite charge. And their results showed that it was affected in the exact same way. So there wasn't a measurable difference between matter and antimatter, the effects on its motion in a gravitational field.
Okay, what is antimatter, bro?
It's matter with an opposite charge, like a proton and an antiproton.
With an opposite charge?
Yeah, so an electron negatively charged, positron positively charged, but they have the same mass and other properties.
Okay. Antimatter just sounds like an insane phrase. So what I want to show you real fast is this, because I don't even know what antimatter is. I mean, I understand what you're saying, but it's a ridiculous phrase. But we're going to.
You don't accept the existence of antimatter, or you're just skeptical about it?
Well, yeah, I don't even. That doesn't even make any sense to me. Antimatter, like, what does that mean? Like, it just isn't tangible. Just name, right? Like, it just.
But do you understand, like, how it was predicted from Dirac's equations? Like, do you understand, like, the reason why it was predicted by Dirac?
Yeah, because they used an ether framework, right? Like Dirac point blank said, like, we are rather forced to have an ether. So when you assume there's an ether, you understand there's equal and opposite reactions. And that's all that they're hijacking there. And that's why I'm about to show you this paper, which I feel like you should have seen this paper. It's called The Electromagnetic Nature of Gravity.
Is it that Mies paper?
Yes.
Well, the Mies paper is interesting because I believe in it, it specifically says that if this electromagnetic nature of gravity is correct, then antimatter should behave oppositely. So this CERN experiment from 2023 seems to debunk this Mies paper.
Okay. I don't know anything about the CERN experiment. I'd have to actually read it, and then it has to be. So basically, no one else in the world can verify this. I'm guessing, right? Because CERN uses just gigantic magnetic fields and then reifies particles. That's what it actually does. It uses gigantic magnets. That's all it's doing. So it is intrinsically electromagnetic. Everything that they're observing is based on electromagnetism. So this claim of antimatter is kind of goofy, but that's what I'm challenging the antimatter. I'll happily look at whatever test you're talking about, but I'm not just going to blindly believe it, right? But let's just read what he's saying here. You said you read it. In this way, the gravitational constant expressed by equation 21 is positive for both matter and antimatter. Gravitation forces are attractive between bodies of ordinary matter as well as between bodies of antimatter, but they should be repulsive between matter and antimatter according to Newton's gravitational potential, since they have positive and negative masses following the mass-charge equivalence. And what you're saying is that they're not repulsive. Is that correct?
Yeah, there's not a repulsion there. That's what CERN was showing, at least, anyway. And yeah, it's not like you can replicate this in your backyard or whatever. It's it's hard to get hold of antimatter in the first place. It's much more expensive than gold, and not many people have access to a particle accelerator. So
I gotta be real with you, man. CERN claiming something about antimatter isn't really gonna be too particularly satisfactory for me, because what I can do in reality, right? And I will say, if we have to go as far as apparently in this last year, CERN did something with antimatter to show it's not possible. We're at least making progress, I think, maybe. But the questions why do positive and negative things not fall at different weights? Or why doesn't positive go up or negative go down? Why don't they go opposite ways? These questions are just showing that there's a lack of understanding in the actual position, for example, that I hold, right? And so like I think we should go through this a bit step by step, and then we can figure out like, is this CERN thing reliable? Like, are they running it through some type of interpretive computer model? Like, exactly what is it? Are they reifying antimatter, et cetera? Are they hijacking the ether like usual? But because Dirac used an ether model. It's all it is, equal and opposite reactions. Gravity shouldn't have an equal and opposite reaction, but in your paradigm. But this is, I guess, to not get it too convoluted, right? Let's answer the first question. If there is a downward electric current, would that create a downward bias?
For positive charges, I can accept that, but for negative charges, I'm still not convinced.
So if there's actually like downward electric pressure pressing on all matter, and it's actually all over the Earth, which is where we get like these crazy numbers here of like 700 megawatts with such a large current coming down all over the Earth, right? So you think that a negatively charged item would not be affected by it?
It would be affected. It would just have an upward bias, not a downward bias.
Okay. Now, then what you're saying is that all negatively charged objects on the Earth have an upward bias because the downward current is provable and measurable. So if what you were saying was true, and that would mean that all negatively charged objects on the Earth have an upward bias. So are you willing to stand behind that claim?
Well, that what would seem to be implied by Feynman's paper there. So yeah, although I think that since he was specifically talking about this, like these electric currents being conducted by the air, that in a vacuum, such as at CERN, that we would not observe those effects.
Oh, sorry, I muted. Okay. In a vacuum, we still have vacuum permittivity. Okay. There is no way to remove it. For once, of course, there's no such thing as a perfect vacuum. And I'm not being like pedantic. I'm saying
I
like,
can agree with all that.
So there is still charge there. And we know there's also like, there's the electromagnetic vacuum in general, where like the charge changes. The amount of electromagnetic energy in the vacuum fluctuates and changes as if it's coming from somewhere. We also know that the vacuum has impedance, 377 ohms, impedance of free space. So there's something in that vacuum chamber. It isn't nothingness, right? And there is vacuum permittivity. There's electric permittivity and magnetic permeability in the vacuum. All that to say, whatever object's inside the vacuum is interacting with that medium. So that's still there. And we shown that even in a Van de Graaff generator, whenever you take like a voltmeter, you can measure the vertical electric gradient, like increasing as you go up from the ground, even inside of the Faraday cage. Yeah, but so like I guess the point I'm making here is, do you think that we would be able to notice that all negative objects have an upward bias?
Yeah, because at that point, right, the effect would be very small, but I wouldn't say that, I mean, there might be ways that we could notice it. I wouldn't be able to say authoritatively either way. But really quick, do you have like the source for this saying that even within a Faraday cage we can observe this electric gradient?
Yeah. Zach did it. We did it. We actually did it ourselves. So I mean, I'm assuming it's obviously can be done by someone else since Zach did it, but I can give you that experiment and we can redo it if it isn't satisfactory for you. But yeah, this is the important part.
So you trust Zach a lot more than CERN, right? That'd be fair.
Well, yeah, because I can go do what Zach did. And it's not about trusting someone. It's like I can do it. Like I made objects float in my office. Yeah. Right? I'm not doubting that. Yeah, but what I think is important, bro, is like if the critique of the question is would a downward electric current cause a downward bias? And so if the answer is for positive charges, not for negative, well then you're insinuating that everything that's negatively charged would be have an upward bias on the Earth. And so, like, is there any evidence for that? Like, is there any measurable evidence that negatively charged objects have a bias up? Because in reality, they're going to still have a net bias down, certainly with any type of material composition, because they're going to then have a buoyant relationship with the medium, right? So a vacuum is going to increase that. Now it's going to be even more dense in relation to the medium, right? So like that pressure mediation is always going to take place. There's just a downward bias on top of that. Now you can overcome it. So for example, like what we do with the Van de Graaff generator is we actually, I'm supposed to be showing Discord. What we actually do is we take the two metal plates and say we put like the quote unquote positive on the bottom plate. So when we start to charge it up, it flips the field, right? It flips the polarity of the field. And when that happens, the object goes up. So you can show that by flipping the polarity of the field, an object will go up, but there has to be something like a iron filing or hair or styrofoam, right? Because it has to be light enough that that amount of charge, which I think is like, it's still a decent amount, relatively speaking, to make it go up. You have to have enough in relation to that weight of that object to make it go up. As soon as you put something heavier in there, it won't go up. That doesn't mean that physics changed and all of a sudden that the polarity of the field didn't change the effect on the object. It just means that the object is too heavy. You need more charge. So that's what we observe on the Earth, right?
So this is just weird to me because I would accept what you're talking about with like those, capacitor plates and everything, but I don't know, like, how should I phrase this? Like, essentially when you're saying that the charges have to overcome the weight, I thought that you were saying that, like, it just sounds like you're just saying, oh, they have to overcome gravity, but you're saying that it's an effect of relative densities now. Is that?
It's not like an either or situation, right? So there's a downward electric bias on the Earth. Everything is trying to seek equilibrium, so it's going towards the ground. Basically, there's tons of energy coming from the sky, which your side acknowledges, it's just measurable that we have electromagnetic energy come from the sky and really
cosmic rays,
Sure, that's what they're called, yeah. So that's always pressing down on us in like really crude terms, right? Just pressing down on us. All objects are within this realm that's being, gently pressed down upon. So to overcome it, right, you're going to have to flip the polarity of that area, that field, or you're going to have to introduce enough charge so that will actually overcome the bias. But it's not just the bias. If you were able to put a pause on things like density, then sure, you could just overcome that weak, say 10 microamps per square meter, or depending on the surface area with the surroundings, blah, blah, blah. But we also have another effect. Both variables are relevant, right? The other effect is that an object is more dense than the air. The pressure mediates between the two, giving it a buoyant force, right? And so that buoyant force is strong, bro, right? Like if you take a beach ball to the bottom of a pool, like it's gonna shoot up. You know what I'm saying? It's like a strong force. So that buoyant relationship is stronger than the weak downward electric bias, right? So that's the point. And I guess this is the major point here. It's like we can prove this. So I can actually measure the downward electric current. I can measure that the higher I go, the potential increases. I can measure equipotential on the Earth. I can then do an experiment where I'm like, okay, does electrostatics or the electric field, does it cause things to go up or down? And typically things go down, but not all things do go down, right? So does it cause things to go up and down? Well, we're going to do an experiment. Naturally occurring observable phenomena, some things go down, or things go up and or down. Okay, now we're going to propose a hypothesis, which is a cause and effect relationship test. So if we manipulate the electric field or electrostatics, we will then change or manipulate or vary the effect of things going up and or down. So we're presuming the cause to be, say, the electric field or electrostatics, and we're going to now vary it in our test to see if that really is the IV. And the independent variable is what we're varying. So we use the Van de Graaff generator. You can just go look at it. You can just naturally look outside. It happens. This experiment happens by itself with thunderstorms. All of a sudden, beetles start flying everywhere. Your hair starts sticking up, etc. Bumblebees have non-contact pollen detachment because they increase charge over the flowers. And during certain thunderstorm activity, their non-contact pollen attachment is even more effective because they're charging more. So we've manipulated that variable and we showed all of a sudden that little piece of styrofoam, that hair, it goes up. What we've shown for sure is that with an experiment, you can manipulate the variable of the electric field or electrostatics and change the rate at which things fall and even the direction that they fall. So the direction and magnitude, of course, being vector. So you can manipulate the vector of an object. And so we've established that cause and effect relationship. Like we're going to set that on the table, boom, scientifically tested, verified directly. So it's measurable, it's real, it's physical, it's testable. We verified it. Now there's an additional claim on the table. And there's a claim that there's something else called gravity and that it's the bending and warping of space-time, and people don't really agree on exactly what it is or whatever. We can't do any tests to directly manipulate that. Can't do any tests. Good.
Okay, sorry, I didn't mean to cut you off there, but there was a lot that I wanted to respond to in everything that you just said.
Yeah, go ahead.
Okay, so yeah, I would agree that electromagnetic forces can add on to like the total force like on an object, and it can like counteract the forces of gravity. Um, I I hope I didn't trigger anybody by just saying that, but yeah, I mean, when you have a free body diagram, you're adding up all of the forces acting on an object, including the pseudo forces, by the way. So, like, yeah, it's just a net force. So I agree that you can change the net force on an object um, with electromagnetics. I mean, I would totally agree with that with your experiment with the iron filing, all this. Also, I've been hearing you talk about the like during a thunderstorm and have how that changes gravimeters and stuff. And can you just provide a source for that? Because I would just like to read that. I'm not
Yeah.
saying it doesn't exist, but I want to be able to read it.
Yeah, for sure.
And then also, I know that I brought this up to you at DebateCon, but when you're saying that there is no test that isolates just to gravity, and you're saying that personally, I would say that when you're saying that you've done these cause and effect relationship establishments with experiments in electromagnetism, I would say that you're not really isolating gravity during those experiments. So you're not. That's what I would posit, is that those experiments are not showing that electrostatics is like the only cause for this net downward acceleration, but could be a potential variable that needs to be accounted for. I would agree. But I would say that you're not isolating gravity when you're doing those experiments. But I would say that there is a variant of the Cavendish experiment that was performed at the University of Vienna in 2021, where they did isolate that they were looking at non-electromagnetic forces. So if you want to say that was some unknown physics and wasn't gravity, I mean, okay, but we know it was not electromagnetic or electrostatics or anything like that,
How do you know
because
that?
they controlled and accounted for that in their experimental design.
How did they do that?
So there were three ways that they did this, and you'll probably object to the first two maybe, but I would like to understand how you would respond to the third one. So the first one was just that they grounded the entire experiment. I mean, yeah, duh. So I know that there's objections to that or whatever. But then secondly, they discharged both of the test masses. So they like shot off all of the charges that were on the surface so that they could eliminate as much of that as they could. And then the third thing, which is what I'm interested in, is that they put a Faraday shield in between the two masses so that no electromagnetic waves could be exchanged between them. So that, to me, I mean, seems like they're thoroughly accounting for any potential electromagnetic effects. And they did observe an actual like registered force between the objects, like as in a registered force measured in newtons. So you can still measure pseudo forces in newtons in experiment. Um, so yeah, I'd just be interested in hearing your response to that. And then if you do have that lightning thunderstorm paper, I would definitely like to take a look at it.
Yeah, I dropped it in the chat, and real quick, I'll read the abstract here. The influence of thunderstorm activity on gravimetric observations has not been considered previously. Based on a long-term high-precision gravimetric observations, we have found that thunderstorm activity induces a quote-unquote systematic error in the measured value of gravity acceleration. Of course, fancy way of saying it's consistent, so it must be systematic, right? The measurements were conducted by CG5 relative gravimeters with a root mean square error of 1 mc/gal, installed on a pedestal of a dedicated geophysical observatory. The revealed effect should be considered non-gravitational changes. The magnitude of this effect is at most 3. I don't even know how to say that. It has been reliably identified against the graph of tidal observations. I think I have the actual PDF, because this is behind a paywall when you look it up. I can give you the actual PDF. I just have to find it. And then as for, of course, when you ground something, so let's say that we ground something, right? What happens when I take it off, when I stop grounding it? Immediately the object starts charging, right? I mean, I used to work in an airport and I had to fill up planes, and you have to ground the plane when it lands. Because if you don't, right, it could be dangerous, and it has to remain grounded, because the moment that you stop grounding it, it starts to charge. So how does that work? Let's think about how that works. Like, well, what's happening when you ground an object? Well, it's providing a route, like an avenue for those charges to discharge into the ground. So as soon as I take it off, it starts charging. How's it do that? Right? Like whatever is connected to it didn't change the molecular makeup of the matter. It didn't change the matter, and all of a sudden it had charge inside of it. It's receiving it from its environment. And it's always going to respond to its medium. Pressure is going to mediate. That's what charge distribution itself is. It's all pressure mediation. And that will eventually, have a fluctuation in the molecular makeup as well, but quote unquote molecular. So the point is that it's receiving charges from its environment at all times. So there is no logical reason to think that when you ground it, it all of a sudden stops doing that. It doesn't, right? It's just that once it receives the charge from the environment, it's quickly distributing it into the ground to discharge it. So it's basically taking that charge as it's coming in and constantly throwing it down, right? In layman terms. So that means there's always receiving charge from its environment. It's unavoidable. It's unavoidable. You're going to have to remind me of the other two, but what I do want to do is, because I have to use the bathroom. So if anyone else wants to also chat with him, or anyone else has anything else they want to say, let's just put a pause on this, because I have to step away for just a couple minutes. I'll be right back. Sorry, but I got faith in you guys. I know I see Alan up here, Gio's up here, Beastical Toby's.
I got you, bro.
All right, cool. And I'll be back in just a couple minutes. And then shout out to the YouTube. I will read all of the whatever donations come in. So again, the links are in the description. We'll read through the super chats when I get back as well. So cool. All right, I'll be right back. Appreciate it.
Yeah, cool. Yo, Critical Base, thanks for coming out to Ozian's event, man. It was nice to have you on, because I could tell you were very familiar with the material. And it was good to have someone who read it,
Yeah, well,
It was a great
likewise,
back and forth.
I like that you're reading these papers as well. Do you want me to drop a link for I can try to find that Cavendish variant that I've been talking about here.
Yeah, sure. What was the Cavendish variant? Sorry, I was kind of tuned out a little bit when I was doing something in the background. Was that something
It
you
was
and Witsit
done
were
by the
discussing?
university. Oh, sorry.
Yeah, you're good.
It was done by the University of Vienna in 2021. And they did a variant of the Cavendish experiment, which I like to cite because it was the most thorough in isolating any potential electromagnetic effects. And yeah, I mean, they did it in a vacuum. They grounded both the masses. They discharged the surfaces of the masses, and they put an oh yeah, so Omnivore's also linked it in the chat, but they also put a Faraday shield in between the two test masses. So that shield basically prevents any electromagnetic exchange between the two masses. So like they still measured a measurable force between those two masses. And it seems like it cannot be electromagnetic in nature based on their experimental design.
Interesting. Yeah, I've been looking for a good paper on like a Cavendish like this. So thank you for bringing that
And the
up.
coolest thing is that this is the smallest Cavendish experiment ever done. The two masses, I believe, were 50 milligrams.
Nice.
So it's the smallest amount of mass that's ever had a measured effect from gravity, basically, or at least in the Cavendish type experiment.
Yeah, I'd definitely be curious to look at it, look at the materials, look at the methodology. I would also say that, like I like, godfather of, cosmic ray theory and, the ionization of the sky, he himself said that the everything was essentially electric and dielectric. So unless you can somehow remove the mass from something entirely, you're never gonna remove electric and dielectric effects and magnetic and diamagnetic effects. Like it's just essentially impossible, right? It's inherent in matter. So, but I'd still be pretty curious to see that. That sounds interesting. I'd definitely be interested to look at the methodology and the materials used.
Yeah, so like you're still going to have like obviously you're going to have electrons and and like positively charged nuclei and things in any kind of matter, but I think the thing about this experimental design was like the implementation of a Faraday shield in between the two objects prevents them from um, you know, having an electromagnetic interaction between each other. So it's not like you've completely like annihilated any electrostatics for each of the individual masses, but in terms of their ability to feel a force from those electromagnetic effects between each other, it does seem like it would eliminate that.
So they're not in a symmetrical field then?
They're not in any kind of field.
Well, so if there's some
In
kind of
terms of
like
electromagnetic field.
if there's some kind of Faraday shield between the two, how does
Yeah.
that prevent some kind of interference in the field?
Trying to understand what you're asking, but
Well, you're saying there's like a Faraday shield between the two masses in this current setup, right?
yeah.
I guess I'd really, or this specific setup, I'd really have to look at the specifics, but
In the
I'm just
chat,
saying from what you're describing, it
yeah.
sounds like there's, it's not necessarily going to be a uniform setup. If there's like a shield between the two specifically, then wouldn't you be creating a field that's not uniform unless they have like specific uh, equivalent shielding all around both sides, I guess, of both masses?
So there is a little, both a picture and a diagram of the experiment in the chat in the link I posted, but um, I don't know exactly what you're asking about in terms of
Oh,
like
I see.
if there's a shield in between each of the masses, then there wouldn't be any kind of electromagnetic field
Well,
exchanged
no, I mean
between.
that's
So
my whole point. Like, so this does kind of confirm what I was suspicious of, is that you're actually creating by Faraday shielding. That's by putting a Faraday shield there, you are like implicitly like affecting the electromagnetic field there. That's just, I mean, that's what that would do. So depending on what those materials are, I mean, you're going to have an attraction or repulsion based on that alone.
how?
They're, like I said earlier, through either a dielectric force or you could have a magnetic force or even a diamagnetic force. That's like inherent in everything, though. Like you can't, like a Faraday shield's not gonna just knock it all out.
Why not?
Because, like I said, in order for the Faraday shield to even work, you have to inhibit a field, right? Like that's the whole premise, is that you're trying to inhibit something. So you're by nature of the Faraday shield, you're imposing a variable.
Yeah, so like the electromagnetic field of M1 is inhibited from affecting M2 because there's an electromagnetic shield in between them.
Yeah. So Yeah, so I'm saying, you know, like, how do you know it's not just the Faraday shield itself that's causing the phenomena?
Because you could do the experiment with just the Faraday shield and not the other mass, and you wouldn't get the same results.
Well, they're still okay. Well, then if you had a uniform reaction to the Faraday, it's a variable that is adding a perturbance to the field. So I don't see
So
like
just
it's
FYI, like in their experiment, they're varying the distances between M1 and M2, the two masses. They're varying that distance, and they're observing a corresponding change in the force felt on one of those masses as they change the distance from the other one. So the independent variable is like that distance of the second mass that's continuing to oscillate. So throughout all of those, the Faraday shield is constantly in place, so it's not varying. So it's not an independent variable in the experiment. So it is controlled.
Yeah, sorry, I'm just now getting back. I want to. So I missed some of this here, right? But I wanted to really drive home the fact that at all times, the object is receiving charge from the medium. It's always going to be having a relationship with the medium electrically. And that's the reason we actually have to ground it. So, for example, if they had not have grounded this test, what would have happened? Well, of course, it would have charged up. So what that means is, as it's charging up, it's discharging it as soon as it can. So I'm sorry, and you may have to repeat yourself, right? But was this in a vacuum chamber?
Yes. I believe it was 10 to the negative 7 millibar.
Okay. So it was in a vacuum chamber. It was grounded, and then what's the other thing?
The surfaces of both of the masses were discharged, and then there was a Faraday shield in between them.
Okay. That is probably the most effective you could be. And so, with that being said, I'm going to go out on a limb here and say that this effect was incredibly small. Right? Was the effect really small? Like what do you know what the masses were made of, or how big they are? Or?
they were
Yeah, they were, I
Fused.
believe, made of gold, and they were, I think, 50 milligrams each. So this was the smallest variant of the Cavendish experiment ever done.
Right. Okay. So that actually makes sense, right? Because that means the smaller the effect of electrostatics, the greater net impact it would have, right? Or net effect. So that Faraday material in between the two masses, right? It's still comprised of matter. It's still within the vacuum, which again, I covered specifically why the vacuum doesn't cut this out, because we have, of course, electromagnetic vacuum. We got people coming up with stuff like quantum foam, blah, blah, blah. We have the Casimir effect, right? And that's both attractive or repulsive, but typically attractive. Good.
This study did say that if they if they were going to do this on a smaller scale, even smaller than 50 milligram masses, which they're thinking about, they said then they would have to account for the Casimir effect, and it would not be negligible as it was in this instance.
Wow, that's pretty interesting, because I was just making a point, but I mean, I would have to see how they somehow justified the claim that they know that it's quote unquote negligible, because I guarantee you that what they measured was incredibly small. Like when you're talking about masses that small, the effect is for sure small. I also know that it's electric. Like I know there's no such thing as mass attracting mass or anything like that. Like that's not real. Like I feel I know that, which means I immediately interpret this test to be automatically electrostatic. So what that means, and it's also a relationship with, like, say the background, right? So what people call the electromagnetic vacuum, or there's also dielectric permittivity, the impedance of free space, all of this stuff, right? The medium interacting with the object, even if it's grounded, it's constantly doing that. So I already know, Phil, I know, I'll say, because I haven't read it, that the effect was very small, right? And the way I know that is because, well, if you actually put something in between the two objects, like a Faraday material, right? Well, okay, that's interesting. For one, isn't that also mass? But anyway,
Okay, so well,
good.
can I address some of these?
Yeah.
So the Faraday shield stayed in place as they varied the second mass's distance from the first mass. So like that was a constant. The independent variable was the distance of that second mass that was continuously varying, and it was corresponding with that distance to the second mass that they registered a change in the force felt by the first mass in newtons. So and then I just find this really interesting. You don't think that it's like problematic at all that you're kind of like you already know before even reading the paper, you already know that it can't be talking about gravity and it must be talking about electromagnetic.
No. Like
Earlier tonight,
I don't do that.
or-
I don't do that. I specifically said I'll read the paper. I haven't. I said I feel like I know, because that's what globe earthers typically do. I'm
yeah,
not saying that.
earlier tonight you were just saying that the Globers do that with the papers.
But
that
I'm
you
not.
give
I'm
them.
not saying that. See, the difference here is I'm saying I'm acknowledging a real life effect that we know exists. So you're invoking something we don't know exists that requires reification. I do think that this is interesting. This is why I do enjoy talking to you, right? Because these things are really starting to lay things out in detail here, right? Which is where this notion that it's been such a terrible argument this whole time. Well, then why would this precise of a test of a Cavendish, right? Why would they be so overly concerned with electrostatics, trying everything in their power to control that variable to find gravity, if some everyday high schooler can go and do it? It's because they know that it is, in fact, a major problem to attempt to isolate quote-unquote gravity beyond electrostatics, because that variable can never be eliminated. The most you can ever hope to do is to control it the best you can. The problem with it is that it's constantly in a state of flux. It's constantly fluctuating. You can never truly control the variable of electrostatics, right? You can never be like, I know it's this amount. And so now that we've accounted that it's automatically this amount, then we're good. And I'll read the paper, because I would be surprised if they would ever suggest that they actually got zero. I'm assuming that they just eventually claimed, look, we did the best we could, so we're going to consider this negligible. But I do want to drive home that point. Don't you agree that it's very telling that if I think it's a university, if this precise of a test, the smallest Cavendish ever done, this is in modern times, had to go through this extreme lengths to eliminate the variable of static electricity and its effect on the Cavendish quote unquote experiment, which isn't a scientific experiment, of course, it reifies things, right? Like, that really destroys this whole notion of all these globe earthers running around the internet acting like it's so laughably irrelevant to talk about electrostatics in response to Cavendish. Obviously, this university disagrees, right?
Yeah, I wouldn't try to like mind read the authors of this study about like what their motives were. I think that they just did an excellent job trying to control as many of these variables so that they could isolate specifically gravity as the coupling force. So
That's my point, though, bro. Grayson, that's my point. My point is these people are trying to isolate gravity. So what was their primary focus on? Electromagnetic variables, which goes to show that they know that that's the thing they have to worry about if they're going to try to isolate.
Because you wouldn't have to, on this scale at least, they were saying that the effects of the Casimir effect would be negligible. Obviously, other forces like the strong and weak force wouldn't really be a thing here. So the only other force that you would be isolating for would be electromagnetism. So yeah, I mean, they tried their best to isolate it. They did it in a vacuum. They did a lot of things that I thought were a great job about why this paper.
No, I think that's good. I think that's good, dude. That I want to read the paper because I am quite positive it wasn't like this. Oh, every time we do it, we're getting this same result, right? I would find that extremely hard to believe. To be the first time in the history of mankind that they did that. Okay, it was still fluctuating. They were trying to find it within an error margin of what they had thought gravity would be. But my point here remains, which is they, in the most precise Cavendish to date on the Earth ever done, are hyper focused on static electricity. and it requires them to make baseless assertions like the Casimir effect is negligible. That's just a claim. So if it was smaller, it wouldn't be negligible, but at this size, you can just claim it's negligible. The Casimir effect is admittedly not well understood. They recently discovered that it can even result in repulsion, right? It's also not consistent with the magnitude. The Casimir effect is not a completely understood phenomenon whatsoever. So for someone to come along and say, well, we know it's negligible, that isn't true. And that there's a background that's giving us electromagnetic energy. It constantly fluctuates. We can't even properly predict the electromagnetic fluctuations in a vacuum. So all of these variables are going to show you this result's not going to be consistent. It's going to fluctuate. On the smallest scale, electrostatics is 10 to the 36 power stronger than gravity's been claimed to be, which means you're going to have to completely get rid of this variable to claim to find something that does the same exact thing that's way weaker. So I applaud them. That's the best you could ever try to do, or something like that, right? But it doesn't actually, unfortunately, Cavendish is a losing battle for you guys. Because on the smallest scale, Cavendish is electrostatics is 10 to 36 power stronger.
So, I wish, for some reason I'm having issues logging into my account to see the full article, because the Nature article is behind a paywall normally, but normally I can access it. So
If you can drop it, we can get it for free. Yeah.
But
I put it in chat for you already. If you scroll up,
okay,
it's
cool.
at 12:26 past the hour.
Because they did calculate at some point, I remember reading this in here. I think that they said that by their calculations, the electromagnetic forces involved, even with all of their, control to isolate, would still be only about, I think they said either 10 or 30% of the observed force in their experiment. I'm trying to find that part of the paper.
Wait. So it said. Wait, I'm sorry. Like, can you repeat that? It said what was only that percentage?
Like the electromagnetic effects would only be, I can't remember if it was 10 or 30% of the observed effect, even like despite all their controls or whatever. But they did the calculations.
So they're conceding that like a percentage of the effect is from the electromagnetic variables. And they're then saying, of course they're going to say this, right? Because they did their best. And so they're going to say like, even though you can never truly eliminate it, blah, blah, blah. But like, I don't even see, maybe I'm dumb, right? But that doesn't make any sense to me, because on the smallest scale, electrostatics is 10 to 36 power, stronger than gravity claims to be. So what they're going to have to claim is that they basically eliminated it like to such an extent that the total maximum electromagnetic effect that could be observed there would still be weaker than gravity, right? That's obviously what they're having to claim. And that's an insane claim, because even if it's 50 mg, right? All molecular and intermolecular attractive forces are electrostatic in nature. And on the smallest molecular scale, it's 10 to the 36 power stronger than gravity's claimed to be. Well, you're actually compiling the molecules together to get the mass in the first place, right? So you can't, it's like dropping a grain of salt on the beach and claiming that you found it.
So, yeah, I found the part. They said the electrostatic coupling between source mass position and test mass force can be suppressed well below 3% of the expected gravitational signal. So, they're saying like the electrostatic coupling is 3% below where they're expecting the gravitational signal to be, which I think was later measured. And also, just real quick, they do show their calculations for figuring out that the Casimir force would be negligible. They have the formula for the Casimir force in the article as well. So I don't want to just drop an article you haven't read on yet, but I would be very interested in talking about this when you've done a deep dive on this article.
No, yeah, I'm happy to revisit this once I do, because I don't want the whole show just to be this, but I'm just going to kind of state my position very clearly, and it's going to take me a second, but I'm going to name all the variables, which is what you have to do in physics, right? So it's in a vacuum chamber. That's a good step, but there's something called the impedance of free space, right? There's something called dielectric permittivity, and there's something called magnetic permeability, always in a vacuum, inescapable. There's also something called the electromagnetic vacuum, and the fact is that those variables fluctuate constantly. like electromagnetic nature of like the electromagnetic fluctuations in a vacuum constantly fluctuate, and they're largely unpredictable. Now, like a lot of like quantum fanboys will claim that it's super predictable. No, just deep dive in it. You'll find out that it's not, right? They have a general idea, but there's always these moments where things happen they can't expect. There's more energy than it's supposed to, and it's inexplicable. They don't know where it comes from. It comes from nowhere. It pops into existence, okay? So those are important variables. Other important variables are, yes, you ground it, but there is no such thing as a perfect vacuum. So not only is there electromagnetic energy, we'll say, coming from something other than the air, because if you do the math for the amount of air, like say a few hydrogen atoms per cubic meter, you do the math, like there's way too much electromagnetic effect to simply be accounted for by strictly the air, right? But also the air also has an effect, even though it's like seemingly like the strongest vacuum you can really replicate on the Earth. So whatever is in there is also going to be interacting with the objects. And in fact, one can even argue that like drawn towards the objects because of that charge, and which is pretty interesting, but maybe not completely true because we know how gas behaves. So anyway, so if you include all of those variables, that it's going to constantly be receiving charge from its environment, that it's intrinsically electrostatic, and the molecules holding it together are 10 to the 36 power stronger than gravity's even claimed to be. Yeah, sure, I'll look at their math, but I would love to know how they supposedly do that, because the way you get mass is a compilation of matter, right? So if on the smallest scale of matter, electrostatics is 10 to the 36 power stronger than gravity's claimed to be, how are you going to then take a bunch of those small units, compile it together, and get more gravity? You're going to have to internally neutralize these things. That is impossible, right? That is not actually possible. What they're doing is discharging it the best they can. They're grounding it. They're putting something in between it, and they're trying their best. So long story short, I will read the paper. I'm actually very grateful for the paper because it proves that they know a variable that they absolutely must account for in any Cavendish is static electricity. It proves how difficult it is, really impossible it is to ever actually eliminate it. They're admitting that there's still a number there that it can at least be. And I would just say that they're probably overly zealous because their goal is to verify gravity. And even worse than that, it's like, say that you were able to magically eliminate the variable of static electricity, which you can't, and they didn't. You still have to then just reify the idea of what is there. And then what I'm going to see is like, oh, that effect wasn't consistent. What was the p-value? Did they record all of the measurements? Did they just cherry pick and throw them out when they weren't what they were supposed to be? Blah, blah, blah. So I'm interested. I'll read it. Maybe even try to contact them, see if we can get below the surface. But long story short, yeah, I mean, the Cavendish is a futile pursuit for any globe Earth proponent because static electricity is 10 to the 36 power, stronger than gravity's even claimed to be on the smallest scale. You can't eliminate that variable. It's always in the medium. It's always in the object. It's always in any of the material creating the chamber. It's always in the vacuum. It's also in whatever air is inside the vacuum chamber. That being said, a force being that much stronger, giving you the same exact effect that you're supposedly looking for, eliminates the possibility of you isolating the much weaker force or cause from within that force that's not a force, and blah, blah, blah. So that's that's my position. I like math and nuh-uhs and Casimir effect. I promise it wouldn't count, and whatever baseless assertions of math aren't going to cut it. I'll check it out, and if they have sufficient experimental evidence to back it up, then we can go from there. But I do appreciate the paper.
We can agree to disagree on all that, I suppose, but for the sake of moving on, we can move on. I don't want to monopolize the time here, but there were I have at least one potential answer to one of the questions, and then two questions that I wanted to ask you about the things that you brought up, if that's okay.
Yeah, let me make sure. I'm pretty sure other Globers are scared. Yeah, you're like their hero because you're actually talking. So, yeah, go ahead. Oh, wait. Let me check. Okay, yeah, good. Let me just say this. Guys, again, the link's in the description, and I'm not going to leave you guys hanging. I'm going to go check the quote-unquote super chats on any three platforms, just so you guys know. Locals, and I'll iron all this stuff out. I just want to let everyone know kind of what's going on. Locals is like Rumble's version of Patreon, basically. It's supposed to be completely uncensored, so you have exclusive content. You can have live streams. Once I get up to over 100 people, I can have a little bit of a bigger community, and then over 500 people, you get longer live streams with a bigger community, blah, blah, blah. That's local, so it's going to Patreon's going to be the next one to come at me, I would assume. So trying to get out ahead of that. Both of the other links have monthly memberships. The second one, which is nas.io, will give you exclusive access to the Telegram, and I'll try to also hook up the other people there. I want everyone that's becoming a member, if it's at a certain level, to get access to like the VIP miswits. You also have the free miswits. I don't want to go too long in this because I'll get it all ironed out soon, but there is water, fire, earth, air, ether, 5 tiers on the first link. And so, yeah, you'll just get, basically we'll give you guys exclusive content. We'll have like a hangout, exclusive live streams, blah, blah, blah. So if you were a member on YouTube, consider going and replacing that membership with the links below. And it would be greatly appreciated. And what I'll do is I'll find a way to hook you guys up so you still get the same type of perks as you did on YouTube. And then we can kind of give the middle finger to them censoring us and taking 30% of your guys' money anyway. Okay, go ahead, bro.
Do you have a preference about whether or not I answer one of these questions first or ask you questions first?
Yeah, you can try to answer the question first.
Okay, so I think I have a potential answer, at least for the third one, and I'm curious if you've heard it before or if you have a response about it. But in terms of can high-frequency radio waves and microwaves propagate, through the curvature of the Earth? It's kind of weird language to me, but I think I understand what you're talking about. So what do you think about like tropospheric ducting? Because to my understanding, tropospheric ducting is an effect that happens regardless of frequency.
Yeah, so I've covered this before in the past, but the problem with that is when we actually look at these transmissions and like, for example, how they're used by the military, they're used with like for like 99.9% reliability. If you go with like this claim of tropospheric ducting, which of course is not an actual measured effect. It isn't like they go and say, look, we can see the radio waves are bending here because of these variables. It is merely a theoretical model. And then there's different versions proposed, like temperature inversion layers and blah, blah, blah. Well, the temperature inversion layers change their altitude. The magnitude of those temperature inversion layers also change. And so what that would show us is that the effects wouldn't be consistent. The military wouldn't be able to do it consistently, just assuming line of sight. So basically, it's just a baseless claim, effectively. The only evidence for it is that it must be happening. It's if we shoot the high-frequency waves line of sight horizontally over the Earth, it's going to be received as if they went straight unimpeded. We're going to say it's actually curving parallel to the surface of the Earth, just like when we see too far, they say light does that with observations, right? And it's going to effectively be the same as if it was parallel to a plane Earth and horizontal or line of sight. And that's just a reification fallacy. It's begging the question. But even worse than that, the reliability is a direct refutation of that. Like it would not be reliable and consistent if you're invoking things like temperature inversion layers, right? So there's that. There's also tropospheric scattering is the other big excuse they use. I've covered these pretty in depth, but I would say that's a no-go, and like I'm going to need actual empirical measurements and verification that this is actually happening. I'm going to have to see that the microwaves and radio waves only go so far based on those conditions actually matching, right? So like when the temperature inversion layer is this high, then the radio wave's only able to go this far, but when it's this high, it's able to go this far, and none of that exists. I looked in depth for those things, and they just basically kind of claim it exists, and the military says we just shoot it like it's line of sight, and we shoot it past the foreseeable horizon, and we just assume it must be curving because how else could it get there? So,
okay, yeah, I'm unfamiliar with like the military procedures that you're talking about. I just know about like DXing, like the long distance, more like hobbyist of like these radio signals at some higher frequencies. So I knew that tropospheric ducting was an explanation for those, and those are not reliable. Like you have to get really lucky to pick up like a really long distance radio signal. Like they don't happen every day, at least for the hobbyists. So I don't know.
Sure.
I would be interested in reading about these military applications that you're talking about that are so reliable. And I would just ask, since I haven't read them, do they provide an explanation for at least what the military thinks is the mechanism?
They typically say tropospheric scattering and then they just kind of leave it open-ended. I mean, ducting pops around sometimes, but they have like troposcatter, like with the really high frequencies with the 99.9% reliability, like in the microwave range. They typically call them troposcatter systems, and yeah, I mean they just straight up claim it happened, which is the idea that it's shooting out straight since the Earth is curving underneath it. There's like an area in the troposphere that reflects it back down, like a mini ionosphere basically, but it scatters it in all directions, which would result in extreme signal loss, right? It's a convenient story because the higher the frequency, the higher the rate of attenuation. For example, microwaves are absorbed by water very efficiently. So you are going to have a drop off with distance automatically, but you wouldn't be able to receive the signals as consistently at the distances we do because this location would change. The location in which the tropospheric scattering would happen, that would fluctuate because it's based on all kinds of different fluctuating variables in the atmos. So they wouldn't have 99.9% reliability. So long story short, the military doesn't really care what people on the internet talk about when it comes to like if the Earth's a globe or not. They're like, this works. We need to use it. We're going to use it. If we treat it like it's a flat Earth and we shoot it line of sight, it works almost 100% of the time. It's very reliable. We're going to use it, right? And then obviously they have to try to understand what's going on or have some type of explanation. And so people assume the Earth's a globe. They say, well, ducting's really not going to work here. It's too low, blah, blah, blah. So like it must just be scattering off of something in the atmos, causing some of the signals to get further than they should.
Okay.
So that's basically
I'm unfamiliar with like the military side of it and what they're doing, but it's all very interesting. That's just what I saw as a potential answer. But yeah, I would agree with you that tropospheric ducting is not going to be reliable. So like it's going to happen sometimes. I think it's an effect that causes some of these really long distance like transmissions that hobbyists are picking up that are like super rare.
Mm-hmm.
But yeah, it's not going to be reliable like you're saying. So
can you think of some reasons why it would not be entirely reliable if it was on a flat Earth?
Yeah, I don't really know.
Typically people will be like, oh well, it should work every single time if it's on a flat Earth, but realistically there's like interference. There's all kinds of things of interference, right? So like obviously over water is the best because topographical obstruction is a thing and it constantly will decrease the signal strength. So even if there's like, so the higher the frequency, the smaller the divergence effectively, right? So like even if there's some diffraction around like the topographical obstruction, it gets weaker and weaker and weaker and weaker and weaker. And then if you run across a storm on the way, right, it's going to mess up the signal, scatter the signal. All kinds of things can interfere with your signal. So you kind of have to get lucky in the sense that there's nothing interfering with you all the way there, even on a plain Earth. So let me take this moment to read the chats because I don't want to leave people hanging, and then we'll pick back up. And again, if there's any other Globers in here, you can raise your hand. I'm not kicking you out or anything. If there's anyone else in here that does, of course, think the Earth, in my assessment, defies physics, you can raise your hand. We'll pop you up. And yeah, there's that. Okay, let's read what we got here. All right. Look at you guys. Some people popped in. All right, my boy Alan. Wait, where's the
what's up? I just got back. What's good?
I see that you donated. I was reading you off. Okay, here we go.
Oh, sorry, my bad.
No, you're good. Relativity theory, LOL. I know, right? Shout out to my boy Alan. Thank you for the support, brother. And of course, if you don't know, that's Alan from Space Audits. So go show him some love on YouTube. Space Audits. And they are regularly at Ether Cosmology as well. Flat Earth Fridays on X. And they pop in here. They're usually also at this show. Long story short, Alan from Space Audits. Shout out to my boy. Been burying relativity for a minute. All right. Witness got the first tier water membership, monthly membership. So thank you so much. Greatly appreciated. Welcome to the Misfits, where maybe we won't get taken away this time. Gordzilla 37. F YouTube then. Here, have this. Thank you for the $5 tip. Over on Ko-Fi. Brooklyn, very generous donation, $50 tip. Love the content. Thank you. And thank you for the support and for coming over here, even though I know it's kind of inconvenient. So very generous. Thank you so much. And I'm glad you enjoy the content. We'll keep it coming. Ash, thank you for the $5 tip on Ko-Fi. Hi, I would love to see a video from you covering the old patented technologies that harness. Oh, wait. I gotta get used to this. Oh, this is pretty awesome, bro. This place is actually cool. Shout out to Alan. He's the one that found it. I can show you your guys' messages and stuff. I think it's pretty cool. Hi, I would love to see a video from you covering the old patented technologies that harness free energy, etc. I would love to know how they work. All right, I'm sorry, guys. Be patient with me, but I'm totally going to show their chats. This is cool, bro. All right. Boom, boom. All right, cool.
Yeah, shout out to Coffee, man. Like it sucks to have to go off of YouTube to donate and stuff, but they got a well set up system and they take less than Patreon even. So
I was calling it Ko-Fi. It's Coffee.
Dude, well, yeah, so I made the same mistake, but yeah, it's Coffee.
Okay. Well, shout out to Ko-Fi. All right. There we go. No. Whatever. All right. Yeah. So Coffee is the first link, and I'll shout out the other members as well. What's cool about the second link too is that there's a bot that's automatically going to throw you guys in the VIP miswits, and then if you decide to stop paying, the subscription monthly, it'll pop you out of the private Telegram. But we'll figure out how to get everyone integrated and get everything running smooth. So I figure you cast the net a little wider and see who's not going to censor me this time, right? So yeah, sorry. Now you guys can see her chat. So this is pretty cool. And I'm really was hoping that I'd be able to. There we go. Okay. I'll read it again. Sorry about the discombobulation. Hi, I would love to see a video from you covering the old patented technologies that harness free energy, etc. I would love to know how they work. Yeah, it is a very interesting speculation. Of course, I will denote it as such, but I do think that technology exists. I think Tesla was very clear about it. I think, of course, since there's a background that you're receiving energy from at all times, basically understanding what excites the ether and causes a usable modality would be the primary piece of knowledge you need. And I think that the possibilities would be endless. So that sounds like an interesting stream. I'm not like I think that like Tartaria is an all encompassing phrase and stuff like that, but I'm happy to check it out. All right, let me go to the next one. Oh, whoa. Yo, chill out. We'll get better. Okay. Guys, give me a break. We'll get better. In a world where YouTube decides to take away people's 15 months. Ali Yer, I think I'm saying that right. Can't stop the truth. Thank you so much for the support. I don't know why it's not showing what it is. I can send you guys private messages, dude. I'm totally going to start messaging you guys back for the super chats. Okay, Alier, thank you so much for the support, and I'll figure out how much it is. All right, we'll get better at this. If I could have someone that could maybe help me do this, that would actually be super fire. Oh, very generous. $50 tip. Thank you so much, Ali, for that. That's very generous. Thank you. All right, Flatman B. No worries, bro. The next step forward is leaving Google in the dust. Hey. Thank you for the $5 tip, brother. Flatman B. And oh yeah, it's down there. Okay, cool. Thank you so much. And I agree. This is probably a blessing in disguise. Let's get off freaking YouTube, bro. Melissa F YouTube, which means forget YouTube. Thanks for your hard work. Thank you so much for the $20 tip, Melissa. And thanks for coming over to Coffee, even though I know it was a bit inconvenient. That's why I'm making sure I show you guys some love on here. But yeah, I agree, and thank you for the donation. YouTube hate donate. Claw, thank you for the $10 tip. Much love, greatly appreciated. I'm curious if there's a limit on how long the messages can be. If you guys know, can say in the chat whoever donated. But thank you, Claw, for the support. All right, so this we gotta get a way to go faster, obviously. But Leo Crow, thank you for the tip. You are 100% over the target. Can Globers provide any evidence whatsoever for the sun actually having nuclear fusion? I have found zero explanations for this, even in their model. What's the still man for fusion? Oh man, that's like a crazy question. I wish a Glober would come do it for me. Honestly, admittedly, they don't fully understand it. There's lots of fluctuations with the spectral lines. They kind of change the elemental composition, but not significantly, but they do still change it. They also have something called helioseismology. That's right, you heard that correct. Helioseismology, where they kind of fluctuate it. And then, Alan, are you still here? What's the other heliospheric current sheets? Is that what they're called?
Yeah. Yeah, the heliospheric current sheets. Yep. Yeah,
so they have a lot of leeway with the actual mechanism of the moon in many ways, or the sun in many ways, in their model. But okay, free thinking. I'll try to answer you more in depth, maybe in the future. I don't know enough to like really still man it, to be honest. Free Thinking became a member of Fire their first month. Hey, welcome to the Fire $10 a month tier. Thank you for moving your YouTube membership off of that stupid Grabbler platform. Oh, what a freaking legend. Run Boston. My boy got the first Ether tier membership. What a legend. Very generous. That's $100 a month. So shout out to my boy Run Boston JT, who is a legend. Obviously, if you don't know, you're tripping. Welcome to Ether, bro. First one to get Ether. What a legend. So thank you so much. Very generous, bro. I can't thank you enough. And my boy Adam, extremely generous. Oh my goodness, bro. Much love, brother. Much love to you. I hope everyone's cool with me showing their donations. But $250, bro. That is crazy. Thank you so much, bro. I can't thank you enough, brother. That is incredible. And it's making me feel like I should have asked, because sometimes people weren't comfortable. But thank you so much for the support. And that's crazy generous. I'm like speechless, bro. That's wild. Dude, it's making me think like, do I need to not be showing this on the stream? I don't know, because people have like screen names on YouTube, right? So I'm sorry if someone didn't want me to show them and I did. I feel bad now. So I'm just going to read through them right now and I'll have to figure out if everyone's comfortable with it. I don't even know how to deal with that. So, sorry.
So when they donate, they can opt out and make it private, because when they don't, it shows up on your page publicly anyway. So technically you're not really outing them, because it's already, if they didn't opt into the privacy, they...
Okay. So it wouldn't show up as their name at all.
Yeah, it'll actually show up private. So yeah, when you scroll through, it won't show up that way. So I've seen a couple of privates, and it won't show up that way for the public. So you're straight.
Okay, cool. If someone is uncomfortable with it, let me know in the chat. But after saying that, you can just be private, I think, or you can put in a fake name, I'm guessing. Yeah, because look, Einstein's cousin. So never mind. I think we're good. You still have the names. So, all right, cool. Einstein's cousin. Thank you again so much, Adam. That was incredibly generous, brother. I can't thank you enough. And you've been a good supporter of the channel throughout the year or two. And I greatly appreciate you, my homie. All right, Einstein's cousin, 3959. Just a humble bow, tip of the hat, and a message. Been a daily FED listener for a year or so, and I want to ask you to please keep taking the high road. Toxicity doesn't look good on anyone. Thank you, man. Yeah, I will continue to do that, and I do appreciate the kind words and the support. So thank you for the $5 tip. and yeah, you gotta take the high road, man. It's not worth it. Robert Tozy, sorry if I'm Tazi if I'm saying it wrong. Keep crushing. Thank you so much for the generous $20 tip, and I will do, man. Much love. I feel like there's got to be a more efficient way to do this. Smiley, thank you for the tip. Been about an 18-month journey. Thanks for all your streams. I have a question about the Gaussian surfaces. If two parallel lines are required, is there not a firmament? The firmament obviously being an arc and not parallel to our realm. Okay, yeah, so I try to kind of cover this. Let me go full screen to show you guys. So like, say that there is a dome, right? And so you have the plane Earth, and then say you have a dome. Like everyone pictures it like this big dome, right? But in reality, the Earth is pretty big, and we don't know how high you can go. Say that you can go 100 miles, right? Like that's like super short. It's like right above the Earth, right? Say 100 miles. Like 1,000 miles is still really, really low to the Earth relative to how big the Earth is. 3,000 miles is across the United States. I mean, do we think the container 3,000 miles? I don't know. But what I'm saying is, now imagine like the distance from like a couple states above you. So the firmament wouldn't be that high up, even if it's a dome. So what it's going to do is it's going to come up, and then it's going to just come across, right? It's going to come across, and it's going to effectively be flat across the vast majority of the interior of the Earth. And then it's going to curve down at the bottom, if there was, in fact, a dome like that. And so you wouldn't find the electric fields drop off until you got towards the edges. And this is going to be the case in any scenario because in order for it to remain completely uniform and vertical or perpendicular to the surfaces the entire way, you'd have to have an infinite plane. So towards the edges, you're going to see a difference, which is why when we go to Antarctica, I would love to really make measurements of the electric field. That's where you'd really know the truth. You start getting out and seeing if the electric field changes further and further out south, closer to any quote-unquote possible edge, or where the containment touches down, of course. So hopefully that makes sense, but that's my answer, is that you would still have the ability to have a uniform vertical electric field perpendicular to the plane Earth and then the parallel surface above it, because what's acting as the parallel surface would effectively be planar above you, and you have to get to the edges to really see the difference. So hopefully that makes sense. Intervention. But yeah, thank you for the support, Smiley Beats. We're almost done. Thank you for the very generous tip, Duke Lucum. Sorry to hear about the YouTube drama. Hope this helps a bit. Ya has a way of chipping away at us like a sculpture to a block of marble. Getting smashed with a hammer and chisel sucks, but the end product is worth it if you keep your eyes on him. Much love to you and your family. Thank you so much for the generous tip and for the very kind and profound words. I completely agree, and I think that it's maybe a blessing in disguise. So I'm not like crazy. I was like really kind of stressed out about it. I'm not gonna lie. I was really upset about it, but then I pretty quickly was like, dude, I'm being a little baby, bro. Like the creator's in control. Everything's going to be okay. It's just very frustrating, especially when I know people have been so loyal as a miswit for so long, and then they just come along and like rip it out from underneath everyone. Like that's so annoying, bro. All right, cool. And I will catch back up with any more that come in. So don't think if you guys send anything, I won't be missing it. I will come back for you guys. Let's go full screen share and pop Discord back up. Sorry that was taking longer than normal. I have to figure out a good system, but I actually like that place. You guys tell me how you feel on YouTube, but I personally like the new system. It's cooler. You get like a whole personalized message. So we'll figure out a nice system that can read it off. Okay. Sorry, all you guys had to sit through that, but you got to show love to the homies that are helping making this possible. So I do want to take this chance to Mr. J, are you a Glober? Are you a globe earther?
Yes.
Do you have any exclusive evidence that the Earth flies around the sun?
No, not right now. I just came. I wanted to ask a question about a YouTube channel to you. That,
About what?
there is a channel, Dude Perfect. There's a channel that he went to space. That guy. And,
Okay, yeah. Dude Perfect
have
supposedly
you
went to
seen that
space.
video?
Yeah.
Yeah. There is a video. So have you seen that?
Yeah, where they were quote unquote in space for less than 2 minutes.
So yeah, so what was your reaction? Like, was this guy also lying, and video also is there? So what do
Yeah,
you think?
so you can just get in something to take you up really high in the air, and then you can just fall back down, and you're gonna float for a second. So like when someone wants to go up there and float for more than 2 minutes, they can holler at me. And by the way, I'll go up there. I'm not gonna pay the money to do it, but all these people are like, oh, send Witsit up there, ha ha ha. Like it would go crazy viral. Send me up there. I'll go up there. If I die, you guys know something suspect happened. But my reaction to it is that it's highly edited. It's clearly disingenuous. It's bad faith, and they were only floating for a couple minutes. It looks like it's actually chopped up, which is just why. Why is it so edited? Why we don't have just like completely uncut versions of that supposed video? How come whenever someone else went to that same height, this older lady in the Blue Origin, she said that I thought we were going to see the curvature of the Earth from up there, and she didn't. But of course, whenever they show it to us, then it's this drastic curvature.
But
And then, bro, you got to listen if you want to learn. If you think you were going to come slam dunk on me with a YouTube video, it's not going to happen. Okay, and then what I want you to think about is one of the famous astronauts, Don Pettit, he talks about the ISS, right? Supposedly that's 252 miles up, way higher. He says everyone looks out the front and they see these videos and they think, oh, look at the curvature of the Earth. He said, but the truth is that window acts like a fisheye lens. The Earth is not nearly that curved. It just makes it look like that. It's like a crazy fisheye lens. That's Don Pettit saying that from 252 miles up. And that's because they know if you actually know how to properly do the math, you're not going to see some of these images they show us. So which part is it that you're asking specifically about? The fact that they're floating, because they did that for a couple minutes. If you free fall in like a glorified parabolic flight, you'd be able to float. And the supposed curvature thing is laughable for many reasons, some of which I just named.
I thought that the person that there he wouldn't lie, right? Why would he lie? The dude, perfect guy,
Why would he lie?
the YouTube. Yeah, like
I'm not. First of all, I'm not even suggesting that he has to lie. I'm saying he may have just gone up in an actual parabolic flight and fallen back down. You mean whenever he comes down and the really scripted moment where he says, "So is the Earth flat?" and he laughs and says no. Yeah, he's not suddenly the arbiter of all truth because he went on a glorified parabolic flight, right? Like he doesn't like now know the definitive answer of where we live because he went on that flight. When admittedly you wouldn't be seeing the curvature. People have gone that high, not seen the curvature. Neil deGrasse Tyson will say you can't see the curvature from there, and then even Don Pettit will tell you that from 252 miles, the curvature they show us is extremely exaggerated. You don't really see it from there. So how would he know?
so most probably he doesn't know.
No, I don't think he knows because, like I said, the windows can even impose curvature. Who's to know if they actually even saw curvature? And they gave us this really chopped up, edited, scripted video. So I think it's highly suspect.
I also thought the same, even though I'm a glow believer, but I also thought that he doesn't look that like he didn't go that high. I also think.
Yeah, and it was just edited a lot. You know what I'm saying? But
Yes.
yeah, dude, I'll go up there, bro. Hey, you guys just trust me. If I go up there, I'll be like, I get to record on my own. I get to release all of it. I want to know all of the specifics of what the windows are like. How high are we going? I'll record all of it, and we'll see what's going on. But
Some flat earther must have gone up there, no?
no,
There are so many.
no, it's like super selective.
No one.
It's very expensive, and not just even if you have the money, you still have to be like approved to go in through on the waiting list. And so, like, no, I mean, only a select group of people are going to spend $250,000 to $1 million to go up on a 2-minute parabolic flight, right? So, some people claim they're going to send me. I'm like, dude, stop talking about it. Do it.
Question I had
What's up?
about the curvature. So, sorry, I have not seen many of your videos. I just came to you, so I don't know if you have answered that already. Like, you should be able to see curvature this way, right? So, what about it?
What, see curvature where?
Like, if you go really high, matlab, how do I say, like on a top of a really tall building, you should be able to see like some sort of curvature, right?
Yeah, I mean, they claim that the Earth is so big that you wouldn't see it, right? I mean, you definitely don't see it in a plane. That's as high as I've ever been. It's like, I think the highest I've ever been, like 42,000 feet or something. Like, I've never seen curvature of the Earth. I see the horizon rise towards my eye level, and we're clearly looking out over a plane, and that the skyline in the distance is clearly rising up, and the bottom of it's completely horizontal, and it's insane that people ride a plane and convince themselves they're seeing the curve. But they would say no. They would say no, you don't see left to right curvature at that height. Their model, the way that they've tried to justify that we don't see it once we sent HAL-2 balloons up, is that you wouldn't see it, and you would see curvature directly in front of you, right? Meaning you would see things blocked by the alleged curve, and we typically don't see anything like that either. We see way too far. So yeah, I think you should see the curvature all the time, and we don't. But they get to make up whatever they want, bro, right? So if, like, I'll say this to you, listen to this. Think about it. If you're on a ball, right? Say you're standing on a ball, the ground should be going down and away from you, like away from your feet in all directions. So as I get higher, the ground should be getting further and further down away from me. It should be going down further and further away from me. Yet that's not what we see. We see
Gravitational pull.
Go ahead.
You are together by gravity. Gravity is holding you, so how will you go?
Nah, man. Nah.
What are you saying? Like,
nah, bro. I think we have a bit of a
is
barrier
gravity,
here,
so
but
you are saying there is no gravity, right?
I'm saying gravity exists because gravity comes from the word gravitas, which means heavy. And so, yes, objects are heavy. They have weight. That's a real thing. This idea that there's something pulling you down to a ball is not true. And even if the Earth were a ball, it can't be that anymore. Gravity can't be some force pulling you to the ball. That's disproven even within the globe belief. It's just something we teach children so they can wrap their mind around the idea that they're not falling off the bottom of a ball, right? So there's no actual evidence of what people call gravity. Everything's electric. Yes, there's a downward bias. There's a downward electric bias on the Earth. Everything's electric, and the Earth's a plane, and there's energy coming from the sky down to the Earth. It kind of presses down on us a little bit. That's it. There's no like magical bending and warping of concepts, and I know we have a barrier here, but there is no actual evidence for what people call gravity. 99% of the population doesn't even know what it supposedly is. They think it's a force that pulls you to the ball. Yeah.
Most of the people don't think critically. Like I was also one of them. But recently I started watching your channel. Few videos I watched some of your debate. But I thought there are he's a big guy, right? Professor Dave. So you should have debated him. Then some people are saying that he dodged you and so something about that.
Yeah, so so I reached out to Professor Dave. I reached out to him a couple years ago, like 3 years ago, to set up a debate, and he called me a peon and an ant, and he said he's not going to propel my career, and that I'm not worth his time, and I'm beneath him, and all this crazy stuff. So he could never really debate me. He'd get destroyed, but
I have seen many flat earthers, so I thought you are the best of them. So he should actually debate you, right? Because destroying you would destroy many of the flat earthers.
You would think so, yeah. You would think he'd want to show that I'm a grifter and a con man, like he claims, and show that. But he can't destroy me. Let's be real. Like, I'm not trying to be cocky or whatever. Like, I'm confident.
No, I am not saying that he will destroy you. I'm just saying that he should be.
I know.
You're
saying that he should want to do it. I get it. Oh, and I'm just saying that
that's what I'm saying.
Yeah, but I'm just saying he's not gonna do it. He has way too much to lose, right? And then people will typically say stuff like, well, people can be charismatic and articulate and win a debate even if they're wrong. And that is true. And so, whatever. I mean, like, there are way better people to debate for the globe. Like, Grayson could debate the globe way better than Professor Dave ever could, to be honest.
Speaking of Witsit, would you be down to do a debate on MDD sometime in February with me?
Yeah, maybe. We'll have to work it out. I have like a lot of stuff. I kind of set the precedent that I wasn't going to keep just debating anybody. I mean, I think you're pretty cool. So if we selected like specific topics instead of just like flat Earth versus globe Earth, if we like actually selected topics,
Yeah, I'm down.
Yeah, I could probably do something like that. No, I kind of
just,
told him I'm not taking like just any random debate anymore, but we could do something.
I just visited LIGO last weekend, so I would like to include LIGO in my opening.
Okay. I know that you do message me too, and I'm not very good about responding, but I will try to look. I'll actually put a note down to make sure I respond to you on Telegram.
Hey, thanks, man. I appreciate that.
Hello.
Yeah, no problem.
About modern day debate, I have to say one thing that I have seen your debates, but one thing that happens most of the time is like sometimes you put a point and the other person can't answer, so they are allowed to jump from the topic. Like, I see that many times. So, what is
Yep.
the point of the debate, right? If you say something that the other person will already go to the next thing, right? He will not answer.
Smart.
you
You're a
want to-
smart man, bro. I don't know. I don't know what the point of the debate is if you do that. Do you agree though?
Well, like
What do you think about this, bro? Say that the Earth is a ball, right? Say hypothetically that the Earth is a ball that spins and flies through space. Don't you agree that when people act like that for the globe side on modern day debate, that they actually hurt their side and they actually like make flat Earth bigger? Yeah, isn't it crazy that they don't see that?
Yeah, totally. Because they look like they don't know. Then why are they? If they are not experts, then why are they debating? That is what I feel.
Yeah, it
And
makes you think
sometimes
like,
they-
wait, why do you guys have to be so ugly and use so many tricks and avoid all the questions? And it should be easy to debunk the flat earther. Yeah.
Exactly.
Yeah, man.
Now I'm not saying that I have seen many flat earthers also do that. I'm not saying that just globe.
Sure.
but-
Yeah.
But the moderator should stop them, right? That you can't jump from a topic. You have to first give the answer or say that I don't know. Just take the defeat, right, on that particular thing. But they are just always going from one thing to another. So that's what I think that the hours and hours of time is wasted there. I feel.
Yeah, I agree, man. Yeah, but if the moderator did that, dude, no one would even take the debate. All right, what I do want to do real quick is Alan and Toby. I want to give you a chance if you guys like have any gravy, because I kind of asked if you guys would be here. We always go late. I always do this, but if you have anything that you want to kind of cover or throw out there, let people simmer on, chew on, anything like that, I want to give you guys a little bit of space to ladle some gravy, and then what I'm going to do is pull together all the different if there's any more tips, and then make sure I read them off. So we're gonna read the tips in a second, so don't think I forgot about you guys. Again, links in the description. I'll catch up with you guys if you support. And yeah, Alan, Toby, whoever, if you guys want to take it away. If not, no pressure, dude. I'll keep rocking, but I just figured I'd give you a spot.
Yeah, no worries, man. So Toby, do you want to do LIGO now?
Yeah, sure. I'd love to go over the convolutional neural network real quick.
Awesome, let's send it.
Cool.
You go over that, and then I'll hit covariance on the back end, and we'll call it a day.
This sounds good. So yeah, let me just pull my notes up here. So before I get into LIGO, I'll just real quick touch on the fact that in 2017, they did a experiment using resonance chambers, electromagnetic resonance, and they measured fluctuations in those. But before they actually looked at the data, before they actually looked at the measurements, they used the error weighted least squares regression model, and the error weighting specifically was used to throw out daily fluctuations and seasonal variance, which is like basically exactly what Dayton Miller had measured. He measured daily, Yuri Galev would call it the space effect, and then there's also the effect of the equinoxes correlating with the motion of the sun. So they specifically threw that out in the 2017 experiment that they did to quote unquote verify the constancy of verify the constancy of the speed of light. So with LIGO, what they do is they actually have they don't actually even like look at real data, right? Everything that they look at comes through the lens of a convolutional neural network. I'm actually having some problems pulling my notes up. 1 second.
And if you want to, I can share your screen if you're trying to show something, or if you're just trying to look at notes, then you're good.
No, yeah, there's nothing.
You're good. You're good.
Yeah. But yeah, in any case, so yeah, they just go through like, so there's essentially they've been building upon this concept of matched filtering. And what that implies is essentially that they're filtering for the data that they're looking for before they even look at any of the, like before they draw any conclusions about the data. It's actually called noise. Like that's actually like the, sorry, I'm having like a weird computer problem here. But yes, it's actually called noise. And then they take the noise and they run it through what's called a convolutional neural network. And the first layer of the convolutional neural network is extrapolate the data out across multiple dimensions and add spatiality to it across multiple dimensions. Then they go through and they look for certain shapes within those within that dimensionality. And then they do correlations upon all those shapes. And then they do combinations of those shapes to create new correlations. Then they go through and they remove spatiality from all that data. And then they do normalization. And so basically that's just throwing out a bunch of data. And then after they've done normalization, they do another whole layer of classification. And then after they've done classification, they run through another, what's that last layer called? I can't remember. Unfortunately, I was having issues with my notes.
Is it another layer of the network? The convolutional.
Yeah, it's just another layer of their neural network. Yeah. And so all that is to say, whatever they're measuring, could there be something they're measuring that relates to the sky? It's entirely possible, but whatever they're measuring comes through a computational statistical framework. And so they're not actually measuring anything direct. And so you have to really take everything that comes from LIGO with a grain of salt, because you have to understand it's all viewed through a purely theoretical, hypothetical, relativistic lens. And so if anything falls outside of that, it's just like when they go to test for the Elias effect and they use an electromagnetic brake to make sure it doesn't actually go outside of what it's supposed to do. That's what they're doing here, but in a way more complicated fashion. They're just making sure that they don't get readings that go outside of what they're supposed to see, such as daily fluctuations and seasonal variance. So yeah, like, I wish that we could actually get the real data from LIGO and not just the what they get that comes out of a convolutional neural network. And then not only that, but just one last note on LIGO. The dudes, when they first measured it, like the next day or whatever, or however long afterwards, it was revealed that the first data was like the first gravitational wave that they measured was actually sample data. And they were just like testing the engineers to see if they were going to find it or something, I guess. That came out. Like first they revealed it. First it was revealed to the world. We found gravitational waves. And then afterwards, they're like, oh, actually, we didn't actually find them. And I'm almost wondering, like, did they just get caught? The fact that they planted data to make this happen, to the point that the second time when they measured the gravitational waves, you can go find YouTube videos of the guys that worked at LIGO, and they didn't trust the readings at all. They like went around hunting for thumb drives and like checking their network for bugs and stuff, because they're like, did someone plant data again? Essentially, is what I could gather. The guy literally didn't believe their like big groundbreaking massive gravitational wave experiment, the thing he like devoted his life to. He didn't even believe it for months because of like the psychological games they've been playing with those guys there. So like yeah, like I definitely would take everything from LIGO with a big grain of salt.
Am I allowed to respond to any of that?
Sure, man.
Because I did just visit LIGO this last weekend, and I talked to the guy who was in the control room that night that they detected those first gravitational waves.
What did he tell you about it?
Yeah, I was asking him all kinds of questions because he got like, he PhD from MIT.
Sorry, was that the 2015 one, the first one?
Yeah.
All right, bet.
Well, whichever one, he said it was like at like 3:30 in the morning or something. But he said it was like that was the first one.
Yeah, that's it.
Yeah, and so they talked about how like in that first detection that they spent like months and months trying to rule out every possible externality of like anything else that it could possibly be, because they wanted to be extremely confident that what they were looking at is gravitational waves. And the questions that I have with I get that they go through a lot of like signal to noise, um, like enhancements or whatever, and there's a lot of stuff that like that the data processing goes through. But like I would just wonder about like why is it that like well, okay, there's two things. Like first of all, with the normal like black hole collision that they're detecting, there's nothing that you can really look at the sky to verify that, but they have detected a neutron star collision, which is like a different waveform, and that produces as well as producing gravitational waves. That also produces like a gamma ray burst, and so you can observe that. And so while I was there, they mentioned that whenever they've detected that neutron star collision, they said, okay, like they reached out to optical telescopes and said, hey, we detected a gravitational wave from two neutron stars in this general vicinity of the sky. Can you check to see if there was a gamma ray burst in that signal and then in that area of the sky? And then it was confirmed that there was a gamma ray burst exactly where they had thought that there should be based on the gravitational wave data. So there is some kind of like there's some there. You know what I mean?
It's possible. I definitely think it's possible. But like I said, I just take all of their claims through a grain of salt. And yeah, I think they're probably missing out on a lot of really interesting data about the ether wind.
So was that so the 2015 guy told you that they collaborated that gamma ray thing, or was that after? Or was that a different one?
That was a different one. So that was the very first one that they detected was a black hole merger, but
Right,
the
right.
one that has the gamma ray, that's from the neutron
Yeah,
star collision.
yeah, dude, you can't trust any dude. So, like Toby was saying, dude, they did a blind injection of data, like as a drill, to see if the scientists could detect if it was fake or not. And right before they went public with the paper, they literally pulled the plug and told everyone it was a ruse just to see if they could do it. They don't actually have a gravitational wave to compare to. It's entirely a construct, derived out of noise to fit a model of what they think it should look like based upon what they think it should look like. So it's really not what you think it is, and like they're telling you, oh yeah, we called this other lab and they looked in the sky and they also saw a gamma burst, dude. Like that's a cool story to reify it, but did that guy also tell you that during that first observation that they made for that so-called gravitational wave of the two black holes derived from the Kerr metric, did he tell you that that detection was made while the device was under maintenance and the uh the software that they use to like prevent false positives and stuff was down, like it wasn't even operational and it was in maintenance mode and hadn't even been fully booted up, and they just went ahead and ran with that. Like
So
that's their big reveal for their gravitational wave.
and so what is your source for this information about that first detection being so weird and sus?
Yeah, from LIGO themselves, and the source that you can read from that is from Stephen Crothers. He sources it and then has the LIGO stuff on it as well, like the sources
Okay, would you
summarizes
be
it.
able to send me that?
Absolutely, sending it
Okay,
now.
cool.
Yeah,
In
and then to
in
get
the
it, and
chat?
then to
Yeah.
yep, I got you. And then to get into the mathematical derivation of the so-called gravitational wave, Crothers also points out that under transformation, it's not even covariant. So like they try and relate it to it propagating at the speed of c, to match
Yeah.
Einstein's theory.
Yep.
But they have it, they derive it in a preferred coordinate system so that it gives the appearance that it matches. He breaks down the transformations, and it's not even it's not invariant under transformation. So it's not even covariant. It's not even canonized in the mythology and the mathematics. So it's like these people have a model that they, want to get out of this, and they have, the means and technology to scramble noise and dissect it through convolutional neural networks to get the quote unquote image of what they need of two black holes merging, a little coalescing in the sky.
But do you not think that it's weird that like that detection was the same waveform at both of the different LIGO facilities in Louisiana and Washington?
No, because they can inject that. Like I was just saying, they would have no way of knowing to verify if it's real or not anyway. And they don't like they literally don't know. They can inject it like as a drill. That was the first thing they did. Then you could read about that on LIGO's own website. Actually, I'll link you the source to that one second.
Where are you putting these links, by the way?
Oh, they're in the side chat. One second, I'll get you that PDF too.
Okay, yeah.
Grayson, you got to admit that it's pretty crazy how much the flat earthers look into everything, huh?
I mean, I don't know. I mean, like Alan was saying that this is bread and butter. I mean, Witsit, this is like kind of what you do too. So it makes sense to me that people look into this kind of stuff. I mean, the creationists look into evolution too.
Right, but I guess what I'm saying is like the way that it's kind of portrayed wouldn't really match the reality, right? Where the average person, even people that are very zealous about defending the globe, typically know much less than a lot of the flat earthers, or like certainly the average person, right? So like when the average person hears that someone thinks the Earth's flat and they ridicule them and they think they're stupid and they say they don't even know that gravity exists, and they drop their phone and they think that gravity's force pulling the phone down, and they laugh and make fun. Like ironically, a flat earther's over here knowing, right, like the whole history of it, the differences and the geometries and the actual causal mechanisms and the tests and what the blah 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 blah, where they've looked into all these claims that these people can repeat from Wikipedia. The flat earthers are over here like reading through all of it and figuring out that it's all reification fallacies. It's all just, nonsense. I'm just saying, like, clearly the way it's depicted isn't entirely accurate, right?
I think that you might be a little bit biased because I think that like you and Alan and Toby and like some of your followers around your channel are a lot more well-read than the typical flat earther, but I interact with a lot of flat earthers on Facebook, and I can tell you that a lot of them don't know very basic concepts too.
Sure. I guess just what I'm saying though, you get my point though, right? Like the idea is that anyone that thinks the Earth is flat obviously just doesn't understand basic things, and the reality is that there are people that will know way, way more than the average person, go toe to toe with like even literally like PhD physicists. We could sit on a board 3v3, me, Alan, and Toby, with 3 PhD physicists, and we can go toe to toe with them about the ether wind for sure. And so like that's just not the way that it's depicted. I mean, it's all good. I'm just saying it's not like I don't need confirmation or anything. It's just like a fact, right? Like it's interesting though. It's interesting that that's the case, because it seems like the popularity of the globe kind of relies upon this false narrative that flat earth is so easily disproven that just people that believe in it just lack basic understanding, right? Like that is not correct assessment whatsoever. And
Okay, well, I don't mean to open up a whole can of worms, but I do think that there are some easy disproofs, but
Okay, well,
to
each their own. And I guess another part of it, right? This is why I stopped talking about flat as much and started talking about the motion and how the Earth could be geocentric and stationary. Because what I found out was all the people, like 99% of the people that are zealously defending the globe, they won't even concede on major geocentric points that are just objective within their own paradigm. Like within their own paradigm, retrograde doesn't prove the Earth moves around the sun. Within their own paradigm, parallax doesn't either. Aberration doesn't either. And then maybe they don't know that, but when they're shown that, right, like they can't even admit it. Or like they hold on to Newtonian mechanics, they can't. And like the fact that all astronomical observations show the Earth in the center, and that we had to come up with all kinds of new ideas to explain it away. And I guess what I'm saying is I found out that the same people that are so diligent and stuck in their way about the globe, specifically against flat specifically, those same people can't even budge an ounce on geocentrism. So it's like there's something deeper going on there. It's something deeper. It's like it's just the idea of going against the mainstream consensus. It makes them uncomfortable. It's like embarrassing. That's the actual thing, because I talk to many, many people with credentials that will tell you, yeah, of course, it's a kinematic equation. You couldn't even tell a difference. It definitely could be in the center, blah, 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 blah. So I don't know. What I'm saying is a pretty clearly to me there's a psychological aspect to all of this. But anyway, Alan, are you you good? You got anything else, Alan? You or Toby?
That's it. Thank you, man. Appreciate it.
Yeah, I want to throw this out here real fast, and I'm actually going to pop over on the screen to say it. And I'll even show the Discord for whatever reason. I'm sure you guys don't care to see me, but just so you don't feel left out. All right, I want to point this out. This is very interesting, right? So a lot of people want, and one of the things I was telling the boys that we need to kind of talk about this year is satellites. People, there are like two primary things that people think for sure show that the Earth's a globe. If people are still saying Aristophanes and stuff, it's like, okay, cool story, whatever, bro, right? There's only a handful of these arguments, right? That the typical flat Earth may not answer very efficiently or sufficiently, right? Where it's like, oh, but if the Earth is flat and then the sun's moving in a circle over top of it, it should set here or here, and it doesn't do that. It's like, yeah, because it's in an apparent position, you can replicate it, take a light source, move it over top of a dome, it'll create an arc, it'll actually be displaced from where it's actually at. So that's exactly what we would expect to see either inside a dome or with an azimuthal grid of vision. So if it's an apparent location and there's some type of curvature to what we're perceiving, we can replicate. It's exactly what we would see. That's why it's displaced. We then saw that motion, and then you can take that curvature, right, of how we see it, and then you can make it a globe model. And if that same curvature exists everywhere, then it's going to affect the stars, it's going to affect the moon, it's going to affect the sun, it's going to affect everything. That very ratio of curvature can be hijacked and reverse engineered. So some people will just like ignore that, or the sky doesn't prove the Earth or whatever, right? Not a good thing. And then the two major ones that people think for some reason like prove that the Earth's a globe is and not for some reason, I understand why they think this, but it is, for one, some of them actually can't get past the idea that like NASA, all this stuff from NASA would have to be fake when they claim that they go to space. And they think that all the people have to be in on it, but they don't. And I'm about to cover that. That's one major one, right? A lot of people watch the videos and they see them faking stuff that's from space, and they're like, okay, I'm not going to pretend I didn't see that. I'm not going to start pretending I'm a defense attorney for the government, where like all of a sudden I have to defend the federal government. And there are videos where clearly you see the guy's shirt get pulled back at a sharp angle, like there's something pulling his shirts in space. I'm not going to make up excuses that defy physics to, blah, blah, blah. So the NASA thing, that's one thing that's not that compelling. But these are the two that I think that 2024 is going to be rough for them, because what we've done at this point is we've taken GPS, we've taken the gyroscope, we've taken the pendulum, whether that's Harvard seeing the Elias effect for 18 straight years, which is an absolute death blow. The Sagnac effect and gyroscopes being relative to time of year, so solar motion, altitude, and direction, absolute death blow. So we took the gyro, it became an actual stationary Earth evidence, right? Took the pendulum, became a stationary Earth evidence. And this is about to also happen with satellites. So, and I'm digressing a lot, but the two main ones is they'll say the Southern Star Trails and satellites. These are like the two major ones, and people don't even bring up satellites that much anymore because like it's kind of played out. But I know that in the Globers' minds, the satellite thing is a major one for them. Like all these people work on satellites, aerospace engineers, all these satellites up above us, like we can track them. We know that they're up there. We can see certain satellites. We can even track some of them. And most flat earthers say stuff like balloons, or no, they're not, they can't be in space, or what's in the sky doesn't prove the Earth or whatever. And so they're just like, what, you're just going to ignore that there are satellites? And for them, like, there's only one way it can exist. It's the same way they think only one way gravity can exist. The Earth's a ball and gravity's pulling you down there. Or basically it's doing that, even if we say it's not technically a force pulling you down. It acts just like that for my mind to work. And so if you're going to come replace gravity, you need to provide something that does the same thing. Instead of stepping back and being like, here's the phenomena, what all could possibly explain the phenomena, they think, okay, here's the phenomena, here's what I was told explains the phenomena. Whatever else comes along needs to give me the same type of explanation. And that's like not the right way to look at it. And we covered the gravity one tonight. But with the satellites, I find this to be very interesting. Southern star trails, we've explained in many ways. It can be just a projection that's basically reflected and inverted off of the dome. That's been replicated. Take light sources, put them in the center. It'll literally show on the outside of a dome, and it'll slightly distort them or invert them, make them move the other way. And it's literally just a reflection, but the same lights will be seen in the south, and you would have this go all the way around the plane. So it would look like over there's a certain thing, over here's a certain thing, over here's a certain thing, and although actually it's all a reflection. I will say that would be a crazy coincidence, right? But the preponderance of evidence is overwhelmingly against the globe. If you just find one thing that you're not sure about yet, and somehow that makes you hold on to the globe, that's weird. But anyway, and then we've also talked about azimuthal grid of vision and then how it would change, and we have corpuscular age, blah, blah, blah. Southern star trails, pretty thoroughly explained. We got to develop a better way to really make sure people understand it, because it doesn't seem to sink in with a lot of people, but physical demonstrations will probably do that. Satellites is the main one that I don't hear people answer very good at all. They just say balloons. This is the fact of the matter. I'm trying to help break through some cognitus out there, okay? The truth is that before flat Earth became a thing in modern times, the average person had no idea that there were many, many thousands of balloons above us. That's true. People did not know that. We were not told that. We were told about satellites a lot. Okay, a lot. And by the way, for those of you at home, just go Google pictures of satellites and you're going to get a bunch of cartoons. We're told about satellites a lot and you're literally just going to see cartoons, bro. It's hilarious. But I don't want to hear someone making excuses for why we see cartoons. Oh, man. I froze. Let me come back up here. So I don't really want to hear people give me excuses for why we supposedly see cartoons, right? I just know that that's what we see. We see cartoons. And I'm wondering if everything's about to crash again. You guys can hear me on Discord, right?
Yeah, sounds good. All
right. So with the satellites, this is what is very interesting. Is if you look at their equations, right? They typically use Newtonian mechanics. The only time that they'll say something about relativity is to kind of transform things or to explain away some discrepancies or whatever, right? But they'll account for like a change in velocity relative to the center of where they're moving around. They'll account for actual ellipses in their path, like as in they're actually curving, like the satellites are actually curving, right, in their path, and they're engineering it based on that. They're engineering it based on an actual circular motion with actual inertial forces, one of which is net centripetal inward force, as if, this is just a fact, that they engineer the satellites as if there is, like the universe is spinning around the Earth while the Earth is not moving, creating a force that has angular momentum that the satellite uses. That's what the equations do. What their explanation would be, yeah, you treat it like it's a real set of inertial forces with a stationary Earth, but actually they're pseudo forces. They're not real, but it works out the same. It's as if they were real. That's their explanation. But this is the point I want to make. Okay, we've measured that there's an ether drift, and as you go higher, it gets stronger. The effect gets stronger. Well, like we covered earlier, air is an insulator, but it's not a perfect insulator. And you have a current. Well, as you go higher, you have less and less and less air. So you also have less physical impedance. So with the Elias effect, and I'm giving you guys a lot of info, I get it, but you have a pendulum, and they've shown that during eclipses and other celestial, quote unquote, celestial phenomena, things happen in the sky, the pendulum drifts differently. And typically what they say is, oh, that's not true. It wasn't seen again. No one else could replicate it. That's the mainstream, anti-flat Earth talking point. But come to find out, that's not true. For example, Harvard saw it for I think 17 or 18 straight years. Elias did it more than once. And the people have even written entire papers from the globe paradigm trying to explain why it would happen, whether it's gravitational anomalies during eclipses or whatever. So what this shows is that because we've shown that with that the drift that's typically attributed to Earth's rotation, it changes with altitude, it changes with direction, it has a preferred direction, and it changes with season. That there's basically motion in the sky around a stationary Earth, and that's affecting the pendulum, which is why if something happens in the sky, it changes how the pendulum moves. Makes perfect sense, right? Like the drift is coming from the sky, so whenever there's an effect in the sky, it's going to change how the pendulum moves. So what that shows is that ether drift affects physical matter. it's not very strong all the way down at the surface. Well, it's further away from the source. And again, as we get up higher and higher and higher, the ether drift measurements increase. So it's the closer you get to the sky, the more you can measure this drift, which is an absolute refutation of a spinning globe right there on its face. So that's why I have to say it's just instrumental error, blah, blah, blah. Instrumentally, the error just happens to correlate with direction, time of year, and altitude consistently millions of times or whatever. But this is the point I'm trying to make. So as you're getting further up to the sky, you're getting closer to this drift. We know the drift can affect physical matter. You're getting further up with this drift, and you're also simultaneously having less air, which means you have less air resistance. So you have less air resistance, a stronger ether drift, and you have greater potential, right, as you get higher and higher and higher. So you could easily actually engineer a satellite, right, shoot it up in a rocket. Now, their distances seemingly would be off. Shoot it up in a rocket, throw the satellite out, right, and design the satellite and its route and its trajectory and its mechanism as if it's a real ellipse over a plane. Right, because you can just do a coordinate system transformation from a plane to a globe. You would have ellipses, treat it like it's actually satellites going in real curved paths and ellipses, like there's actually the universe spinning around, creating a real force acting on the satellites, right? And you could, in theory, have thousands of people engineering these things, assuming that the Earth's a globe that spins and that we use Newtonian mechanics, we use real inertial forces, we use ellipses and actual circular paths, but it's just because the math is easier, it works, whatever, but actually the objects are not changing velocity, even though we have to update and account for the change of velocity relative to the center. They're actually not going in a curved path in the Earth's reference frame, even though we have to account for a curved path. They're actually free falling in a circular path, in a geodesic curve, even though we have to treat it like there's actual force acting on it. There is no actual inertial forces, they're just pseudo. So then you could just throw stuff up there. If there's an ether drift with less air resistance, even more conductivity, more ionization, the higher that you go, right? And who knows what else is happening up there. So the military goes up there and kind of figures out how to get something to move perpetually within the field lines over the Earth in this torus field with the ether drift, the giant vortex. You could just have tons of people designing satellites, thinking they're doing it on a globe that's spinning, flying through space, but in reality, they're just using the actual real inertial forces that their model claims aren't there, but they have to account for to put them over top of a stationary plane with the ether drift. And now, obviously, that's way too long. It has to be way more curated and concise so people understand it. But my point is, what's going to happen by the end of this year is the same thing that's happened with everything else. And that's why once you go flat, you don't go back. That's why people say that. It's because the deeper we dig in all of this, we find out not only is it not proof of the globe, it destroys the mainstream model. Every single time it's shrouded in pseudoscientific reification fallacies that are contradictory and make no sense and blah, blah, blah. The satellites are going to be absorbed by flat Earth. And when that happens, and we start getting insiders and we start talking to them, it's game over. I mean, they got nothing left at that point. So that is a big rant. I didn't even plan on doing it that long, but I just wanted to throw that out there for you guys to kind of think about it. If you guys know any aerospace engineers or have any ideas of how to have some connections or some talks or some I think you can have access to some things that are maybe not typically publicly accessible or any ideas. I think everyone should start to refine their response to the whole satellite question. Because whenever a person says, well, how does Flat Earth explain satellites? If they're actually falling around the globe, we can explain it. And how do they stay up there? What are they? How close are they? How are they moving over the Earth? And then people just say balloons. Well, then that person feels like, so you just have to ignore like all of this evidence. Now, a lot of the evidence is a little bit shoddy, but there does seem to be some evidence that there are some things moving around quite fast over top of us. And so that's not a good look, right? And we should refine it. Okay, I'll kind of stop ranting. But anyway, I just wanted to throw that out in the ether, if you will. I think that would be one of the smoothest tricks played on people ever, right? It's to have all these people engineering it, assuming one thing, but just right in their own face, in their own math, in their own engineering it a totally different way, but never thinking twice about it. So no, there's not tons of people in on it. It's nothing like that, right? And you would just take the military, kind of, reverse engineering a globe transformation, a coordinate transform, and then like this Newtonian, Einsteinian, ECI, ECF, stationary frame transform, and then boom.
Reference frame Polaris.
Yeah, man, it's pretty crazy to think about that.
Last Tuesday, Ether Cosmology, Alan exposed that pretty explicitly, that they just use Polaris as the reference. So, yeah, he just dropped a couple pictures in the chat there, and yeah, it's pretty it's a pretty big problem for the globe.
Spaghettios. I know that was like a big rant, and also my camera went off. I think we're back. Hey,
It was really important though, and like well founded, because as we look into these topics more thoroughly, instead of just hand wave dismissing them, we see that they are accounting for effects, and it's like, so what are they accounting for? How have they co-opted, classical mechanics to account for relativistic effects when, they put forward this framework of free falling in a geodesic, and you can't measure it, but you can measure it on Earth, but you just can't measure it when I'm sorry, you can measure it in the lab frame on Earth, but you can't measure, any speeds outside of that. But you just have to assume them through you assume them vicariously through transformations. So this is like a really important subject because we're, getting closer and closer to figuring out the mechanisms for these things.
Yeah, man, you assume them through the transformations, man. It's freaking crazy. Yeah, very, very cool, bro. Let me read some more of these chats real quick. Smiley Beats, been about an 18-month journey. Thanks for your streams. Thanks for all your streams. I have a question about the Gaussian surfaces. I already read that one, but thank you anyway. And Duke Lukum, sorry to hear about the YouTube drama. Hope this helps a bit. Yeah, has a way of chipping away at us. I already read that one as well. Sorry again. Ali Yer again. This is for all the nights your videos kept me entertained while driving through the mountains. Hey, very generous tip, Ali. Thank you so much. And that's awesome, man. Greatly appreciated. And I'm glad that you don't get too tired of listening to me rant. So my pleasure, and thank you for the very kind and generous support. Greatly appreciate it. Leo Crow, forgive me being stuck on this, but I think fusion destroys the globe model. The idea of the sun's nuclear fusion is an ultimate example of begging the question. Fusion is impossible with axial rotation, even within their paradigm. Also, when are you streaming with Owen Benjamin? Like I said, I don't know enough about nuclear fusion. I can put it on my list of things that we can tackle. I'm really big on the satellite thing. As you can see, I just kind of passionately ranted about it, but yeah, sure. I think the electric sun theory is a good place to look because it points out a lot of the fundamental problems in their current understanding of the nuclear fusion with the sun and just the sun in general, and how like an electric phenomena can explain a lot more of it. Now that it also goes into explaining things that are assumptions that, like, I think we clearly know aren't even true or verified at all. But electric sun theory is a pretty popular theory, even within that heliocentric framework of mind. And so the supposed phenomena they need to explain is oftentimes, reification fallacies, and within, as some people say, Narnia, second law of thermodynamics violation. But it'll help you figure out a lot of stuff they say is wrong with it. When am I streaming with Owen Benjamin? I don't know, man. If someone reaches out to me, I probably would be happy to do that. But I have super busy schedule here. I'm trying to figure out some way to avoid YouTube like really dropping the axe on me, stability wise. So I'm trying to work on a lot of stuff behind the scenes, but yeah, I'm open to it for sure. Leo Crow, one last thing. The reason why you got demonetized from YouTube was because they recently delayed Artemis until 2026, of course. NASA was trending on X because they got completely ratioed by true earthers. They are mad. We are gaining traction. Keep it up. That is pretty interesting. I mean, obviously that is a assumptive correlation there, but Artemis got delayed till 2026, which of course it did. And I don't know if Coach was in here, but I know that we got some type of deal back in the day, and I feel like I've been generous about letting it move a little bit because I'm pretty sure it was originally 2025. And of course, flat earthers sit here and constantly, confidently say they're going to keep pushing it back. And I don't know, the ballers just stick their head in the sand every time it happens. But And then NASA was trending on X. They got completely out-ratioed by true earthers. They're mad that we're gaining traction. Maybe so, because like all I cover is true earth on YouTube now. I don't even really cuss. Sometimes people cuss on my stream, but I don't even cuss. Like, I try to make it where our children could listen to it. Sure, it's alternative cosmology, but get out of here. I don't even talk about the controversial stuff. We move off of the platform to do that. And then all of a sudden, 2024 pops around and they hit me for quote unquote harmful content with no specificity, rip all the members, rip the super chat, all monetization. I mean, it's just insane. Like they're just trying to, it's just one of those attacks, bro. And it's what it is. Leo Koba, thank you for the support. Thank all you guys for supporting on Coffee. Greatly appreciate it. If anyone donates, and I don't get to it during the stream, I'll make sure I read them on the first stream. Everyone that's legend enough to come support me off of YouTube, I'll make sure I always catch up with their streams. I don't know if Rockfin's even working now, so I don't think there's anything to read there. Yeah, Rockfin went down because of the other chat. And let me get over here to this other place here. So we have Nas.io, and this is going to give you exclusive access to the Miswits VIP Telegram. And we have someone that signed up as an annual member, which you get, I think you get 2 months free if you sign up annually. So very cool. Let me find you guys. And by the way, that's actually a very cool site. It's got like a news feed, so we can have our own little social media type of thing. It's got events, so exclusive events. If you're a member, then you get the access to it. So I also really like that place. Nas.io, you guys should definitely consider going out there. And by the way, if anyone signs up for Life Reset, if you pop into Life Reset 1, 2, or 3, then you're gonna get Miswits perks included within that as well for you guys to chew on that. So Carl Sandberg, thank you for subscribing on Nas.io. Sorry, I'm trying to figure out. Okay, thank you for subscribing as a monthly subscriber. I'll have to figure out this stuff better. And Thomas Yates signed up for a year. Shout out to my boy Thomas. Thank you for signing up to be a member for a whole year. Greatly appreciated, brother. And Edward, thank you for signing up for a month. And I will drop that link again. You guys should consider checking out, because I'll just tell you right now, that's going to end up being very dope. That place. If everyone will move over to these two places, I'm going to really hook you guys up, and or locals, which will replace Patreon eventually, I hope, because Patreon's coming at you, boy. I can already feel it. So, all right. Thanks to Discord for being patient enough for me to check through those. And again, the links are in the description to do that. And I'm going to really work over the next few days to build those places up. And they're going to be very dope places, Miswits, uncensored, private access to complete uncensored, private content, private live streams and calls and chats and all this stuff. We're going to make it dope because YouTube's not going to stop us. So get in while the getting is good. All right. So sorry that took a while. Anybody got something they want to say before we get out of here? Because it's already 2. I got to work out. I'm supposed to work out at 6 in the morning, which is freaking 4 hours from now. So, yeah. Anybody up on the stage got something they want to throw in before we wrap it up?
No, good stuff tonight. If anyone wants to come by Tuesday, Ether Cosmology, every Tuesday at 7 p.m. Eastern. And then also we're going to start doing readings on Thursday. We're going to start going through papers. I think we're going to do 7 p.m. Thursdays Eastern as well.
Yeah,
Nice,
and I still had a few more questions, so I know we didn't get time to cover all of them, but I had questions on the equipotential stuff and the lack of dark matter and dark energy in your geocentric model that I was just curious about asking. So maybe if there's time on the next one or something, I can ask those.
Yeah, man. Yeah, it's cool. I mean, I can very quickly say that if you have a background medium, which you guys had to throw the ether out to save your orbit, if you have that, you don't have a dark matter problem. You also, if you're not adhere to relativity or any specific proportionate mass theory of gravity, you don't have that problem. And also you just have immense angular momentum, even if you were to use one of those gravities, which I never would, by the way, from the distance galaxies, where you would actually not have a strictly proportionate mass relationship, even according to some of those dynamics. But long story short, you can have an ether, you can't in yours, so you don't need dark matter. And then dark energies to explain the accelerative expansion, which is used to explain away why it looks like we're in the center. But of course, in a geocentric model, you look like you're in the center because you are. You don't have to claim that the universe is expanding 4 to 8 times faster than the speed of light with some mystical, magical energy that no one can find called dark energy or the cosmological constant to explain the Hubble constant. And then people will say, well, what about redshift? You still have to explain that. Like, yeah, well, electromagnetic retardation within the divergence of a magnetic field would give you redshift, as would attenuation of light. That would explain us being in a giant torus field, why there's more and more redshift further away. But there's also anomalies because the electromagnetic nature of the things we see in the sky are causing redshift, blue shift, certain things to have more redshift, etc. I know that was really quick. I'm sure that was kind of that you're tempted to respond, but we can definitely pause the conversation and we can have it in the future. I didn't want to leave it completely unanswered. Anyone else on the and thank you for being cordial and jumping on, bro. Anyone else on the stage got anything that they want to throw in?
Quality show, bro.
Thank you, man. Thank you, brother.
Yeah, that was awesome, man. Thank you for the show, and it's been an honor and a pleasure, sir. I'm gonna sign off here as well. You guys have a good night. Have a good session at the gym, bro.
Thank you, man. Yeah. So shout out to my boy Alan at Space Audits on YouTube. And cool. I'm gonna let the Discord go. But this is Earth Awakenings on Discord. Link in the description.
You got one more super chat before you dip. Sorry.
Oh, on coffee.
Yeah, from November.
Okay, cool. Yeah. Maybe this is a dumb question, but can you operate a Van de Graaff generator in a vacuum? Good question. I don't actually know the specifics of how effective that would be. I mean, I think technically you could, but would it be really effective? No. So I can't say that I've ever specifically seen it, but logically speaking, the transference of electrostatics through the medium is going to be like obviously significantly less efficient. So I would say not as efficiently, but you could still do it, right? I mean, you can always do it, but it would be way less efficient. So that's an interesting question to kind of look into, though. I wonder what people have done in that realm. All right, cool. I think we're good. Like I said, check out the link in the description if you watch it back. Definitely check it out. It's gonna be an entire community with special VIP events and stuff. So it's going to be way better than the YouTube thing was anyway. And I think they don't take 30%. I mean, they still take like 10% or a little bit more, I think. But on Nas, and I think that coffee is 5, but they can't. Anyway, we're going to merge everything together. If you want to support me on Nas, coffee, or locals, I got your back. Trust me, we're going to put it all together. It's just a lot of work. Okay. Thank you guys for kicking it. Shout out my boy Alan, Space Audits. We got Toby, Ether Cosmology. And then shout out my boy Geo. This is Earth Awakenings. If you want to support the Discord, link in the description. So shout out to them letting us kind of like take over the Discord. I greatly appreciate it. Appreciate everyone sitting in the audience, being patient, and checking us out and supporting this. And cool. I think that's it. I think I also have their Rumble in our description, so show them some love. This place streams 24/7. If you have questions about alternative cosmology or the true Earth, this is the place to go. You can jump in, ask questions, or you can listen to it while you're at work, while you're driving, whatever, to kind of learn about things. So yeah, we definitely want to boost this place up. It's a good resource. Like I said, the thumbnail has the QR code, and then the link in the description is labeled Earth Awakenings Discord. So shout out to them. Okay, cool. I always end up going till 2 a.m. on these shows. It's kind of crazy, but it is what it is. Shout out to the 500 Legends. Thanks for kicking it. And I'm going to go ahead and let the Discord go and then kind of talk to you guys real briefly on camera and get out of here. So much love to everyone in the Discord. I'll jump back in for a second once I end the stream, and I will catch up with you guys later. Much love. And okay, Discord done. All right, and now we're back on stream. I'm sorry I'm not the best at running this yet. I'm trying to get used to it, but we'll figure it out. We had some technical difficulties at the beginning of this stream, but it is what it is. You can see Witsit has Jesse Path blocked. Yeah, of course. I gave him like 50 warnings. Flat out awesome. Thanks. November, thanks. Yeah, no problem, brother. Thank you. Witsit the Crusher? Thanks, Austin. Yeah, no problem. Okay, enough picking on the mentally challenged. I'll leave the ball lovers alone. Let's try to be nice. But I'm considering changing the name of the show because I think it kind of comes off derogatory, honestly. I want it to be more like chill, but I don't know. I haven't decided yet. Thanks. Witsit? Yeah, no problem. All right, let me kind of break down my vision to you guys real fast, okay, just so you understand. If you go to the top link, that's coffee. That's where we're able to tip during the streams. I'm going to find a way to make a really smooth transition to where I can show them throughout the stream on the screen, right? So it's like better than YouTube anyway because it'll be like actually on the stream with the playback value. Obviously, it won't be in the chat, but YouTube sucks. So it is what it is. They may give me my appeal back, but they may not. I don't want to rely on them anymore because honestly, bro, like, yeah, I mean, I don't want to say too much, but like, I needed that. Like, I need that to like pay my bills, right? And like, I'm hesitant to even say it because you're gonna have all these haters coming at me like, oh, grifter, blah blah blah, all this nonsense. Like, whatever, bro. Like, I put a lot of time and effort into this, and yes, I occasionally get some money through YouTube. It's not like a crazy amount of money or anything, but it definitely was part of my bills. And so for it to abruptly be pulled out from underneath me was not ideal, but obviously I'm not going to let them, make me quit or run off or stop doing it. So we're going to figure it out. So shout out to everyone that has or does rally around me to help me out with that. Also, another way to help me out is the life reset. I think it helps me out, but it helps you out as well. So obviously directly supporting helps me out. And if you get into life reset, then I'm going to hook you up with a lot of the perks from the Misfits anyway. And that's already being super awesome, bro. Like, people are really creating like these dope networks, and we're figuring out all these different like things to help with people when they're pregnant or after they're pregnant or before they're trying to get pregnant, and women's groups and men's groups and like logical fallacy show and stuff like that. And so if you want to check out what all's there, check out if you go to join our personal development community, click that link. It's the 4th link in the description. If you want to at least read about and check out the community, that's the forum, and then the website's underneath that we haven't finalized it yet. But that's going to end up being really cool. We're going to work with Misfits. It's been a nice collaborative effort on many things, but it's an awesome community of people. It's going to be so cool. So if you need to like fix your credit, if you need to figure out how to start a business successfully and how to get some type of funding, if you need to figure out how to get rid of the tax issue, or if you need to like just not have to worry about the government all over you in general, if you need to figure out some trauma integration or just healthy processing of emotions or integrating emotions, or how to control yourself or be like effective meditation, effective communication. We have like another course that's going to like help people deliver uncomfortable truths or just these truths to people, to prioritize consent in the best delivery method, show people how to really learn different aspects of logic. All of these courses are incredibly valuable individually, and we're putting them all together because we want to create this beautiful community of people where we can really have the true earth take the next step up. So I don't have enough time to really explain the community to you guys, but trust me, the vision is awesome. It's already starting to come together, and it's going to be very cool. So we have our daily tonic hangouts. And so the idea is that people come in, they participate in the community fast, they help get clean, they detox, and you have this network of people that are going to help you do it. And people are healing all kinds of ailments, bro. It's like super inspiring to see like all these different ailments being like, I hate seeing people trapped down with trauma when it comes to big pharma. Like, they're put into fear and they had traumatic experiences, or they have traumatic ailments typically coming from big pharma or coming from our environment or heavy metals and all this different stuff. And yeah, that's all I will say, honestly. But like, it's really inspiring seeing people detox and get clean, and then being able to nourish themselves with like these tonics that are basically meal replacements that are like superfoods. And I really want to see people elevate, like you guys. I want you guys to be here longer. I want you guys to have healthy families and to make children and to be here for your children and to have healthy babies and raise your babies healthy and have like homeschooling resources and like success where we network together and we work with each other and we become self-sustainable with electroculture and permaculture and regenerative farming and like getting ourselves financially straight and getting ourselves legally straight and getting ourselves emotionally and psychologically straight. These are like really important things for us to be more effective as a community. And long story short, sermon will be over after I say like what's really the importance of figuring out about stuff like the fact that the Earth's in the center, the fact that this place is special, that it's like a majestic realm, that we were misled about it. Like we were misled about our importance and where we come from and what the Earth actually is, or like what's the importance of it. Like what comes from that, right? Like the realization that this place is like incredibly beautiful and majestic and like intertwined with this metaphysical, and that we're powerful, right? And I'm not trying to be cheesy or anything. These are like real facts. Like we are powerful and we can manifest things, and we end up like kind of we get overwhelmed with like feeling like we're alone because like we're the only truther and our friends and family don't understand us. And we have these people we talk to in the chat sometime, but like it's easy to get mad or feel like upset, or then to have like a scarcity mindset, or to live in fear and be like, look, now that you know the truth, look at all the stuff the system must be doing or lying about, and I'm by myself and blah, blah, blah. And I want to get rid of that as a community, right? I see a lot of division and hatred and fear, and that's stupid because we're figuring out like, no, we're actually super powerful. You have to trick us to do anything because of how powerful we are. And this place is incredible. You could never stop it. You could never truly ruin it until like the creator allows it to happen, because it's part of his plan or whatever. And I think you guys get what I'm saying. I really hope that you guys are kind of inspired by some of that and consider like partaking in our community, where like you can hold me accountable, I can hold you accountable. Like, did you work out today though? You're supposed to work out. Like, okay, well, what did you do to be fit, like active today? We have like fitness accountability calls, or like and voice calls, or like we are setting different daily, weekly, and annual goals, and we're helping hold each other accountable in men's groups and women's groups. And there's just so many different things. I could talk forever about what all is going in there, but the vision is like truly a place where we can we're not alone, and we can work together, and we can be successful and self-sustainable. We don't need to work jobs that we hate. We don't need to like be scared. We don't need to be overwhelmed or feel alone. And then it'll also migrate into like kind of like matchmaking, right? And like putting families together and inspiring like family creation and stuff like that. Yeah, it's a beautiful vision, man. And I encourage you guys to check it out. I really do, because I think you guys will benefit greatly from it, and it's starting to manifest, and it's going to be very cool. The form is right there, just to kind of fill out and kind of see what all is there, and then we'll go from there. Okay, cool. There's that. A lot of stuff going on. We got like a few different debates coming soon, so I'll keep you guys updated because I'm really tired. I need to get up kind of early. So thank you guys for kicking it. Shout out to everyone that supported. Like I said, if anyone supports from like now to the next stream, I will read you guys off. What I'll do is I'll check off streams. I'll check off any type of support at the beginning of streams, and then I'll read them in like the middle and throughout the streams and at the end of the streams, so that we really prioritize anyone that's helping me out in this situation where like I have trust in y'all, but it's not a good situation. You know what I'm saying? Frankly. And I'm trying not to like be overwhelmed with it or whatever, then I'm going to have your back like tenfold if you have my back, right? So if anyone sends anything on Cash App, which is $WitsitGetsIt, I'm going to read them all. If anyone sends anything through PayPal, link in the description, I'm going to read them off, and you guys get it. Okay. And then the coffee, whether you're a monthly or singular donation or Nas, that's going to be an awesome community, or locals, which will be like, it'll end up replacing Patreon, I think. Cool. I know that was redundant. I hope that you guys aren't too annoyed, but I have to like address the elephant in the room. It happened a few days ago. It's really annoying, but yeah, they're not gonna stop me, so it's all good. I love you guys. And I'll catch up with you tomorrow. So seek and speak truth unequivocally. The weak find contentment in the consensus of ignorance. So who cares what other people think? The more that we begin to try to talk to people about this or discover more, all you find out it's the same reoccurring theme. Like people are just afraid to not fit in, right? But of course, what's true is rarely popular, and what's popular is rarely true. So seek and speak truth unequivocally regardless, because it doesn't even make sense to conform to that knowing that is the case. All right, I'll catch up with you guys maybe tomorrow if I can get the stream done. Got a lot of stuff going on, but I'll let you guys know. And much love.
science just a big charade, making theories they just can't explain on philosophically biased claims. Days of days, we break away just like a renegade. So pay attention, gonna get a grade. With school and globus till they all awake. School and globus with diplomas and a chip on the shoulder. Debate is over, mind is sober, solar system disclosure. Can't go back once you heard the facts. We make a pact, never take the backs. School and ballers and the followers that give them the dollars. They try to holler in the chat that you're a fraud, not a scholar. They hating y'all, that's why they attack. The earth is flat no matter how much they laugh. Days of days, pseudoscience just a big charade, making theories they just can't explain on philosophically biased claims. Days of days, we break away just like a renegade. So pay attention, gonna get a grade. We school and globus till they all